You trust the ground beneath your feet. It feels solid. It feels permanent. You trust that if you drop a cup, it will fall down, not up. You trust the air you breathe to fill your lungs, and you trust the sun to rise in the east. Above all, you trust that the laws of physics are set in stone, unchangeable, predictable, and fair. Gravity pulls down. Light travels fast. Atoms hold together. This stability is the foundation of your sanity. It allows you to plan for tomorrow, to build cities, to fall in love, and to sleep at night without worrying that the world will simply dissolve into a meaningless soup of mathematics. Science, for the most part, reinforces this feeling. We are taught from a young age that the universe is a machine governed by strict, predictable rules, a clockwork mechanism that makes sense. But here is the problem. That feeling of safety is an illusion. It is a psychological bias, not a physical fact. It is a biological hallucination designed by millions of years of evolution to keep you sane, not to show you the truth. When physicists look at the equations that actually govern reality, the raw code of general relativity and quantum mechanics, they don't see a rock-solid foundation. They see something much more fragile. They see a balancing act. The math suggests that our universe might not be the final, stable version of reality. It implies that the rules you trust are local, temporary, and easily broken. And there is one specific place in the universe where the rules don't just bend, they shatter. There is one object that stands as a monument to the destruction of logic. We are taught that black holes are just dead stars. We're told they are simply objects with a lot of mass squeezed into a small space, like a very dense sun. But that is a comforting simplification. It is a bedtime story for adults to keep them from staring at the ceiling at night. When physicists actually look at the math describing a black hole, they don't see a star, they don't see an object, they see a glitch. They see a terrifying error in the programming of the universe, where the laws of nature, cause and effect, time and space, information and order are violently deleted. A black hole is not just a hole in space. It is a hole in our understanding of existence. It is the place where math goes to die, and the things that happen near them and inside them are so disturbing that they keep the smartest people on Earth awake at night. We are not talking about the simple danger of getting sucked in. That is a physical threat, like a shark in the water. We are talking about theories that suggest black holes are fundamentally breaking the logic of reality. Theories that suggest they are portals to universes that shouldn't exist. Theories that suggest they are erasing our past. Theories that whisper that we might be living inside one right now. Welcome to Distortion. Today, we are going to stare into the abyss. We are going to explore 7 specific theories about black holes that terrify scientists. We will move in a spiral, starting with the physical horror of what happens to your body and descending deeper into the existential horror of what happens to the truth. By the end of this broadcast, the night sky will look different to you. The darkness between the stars will feel heavier. Because once you understand what is hiding in the dark, you realize that the silence of the void is not peaceful. It is hungry. To truly understand why scientists are terrified, and to understand the gravity of the situation, we first have to deconstruct your relationship with gravity itself. You think of gravity as a constant, a friendly force that keeps your feet on the grass. But gravity is not a force in the traditional sense. According to Einstein, gravity is the curvature of space and time. Matter tells space how to curve, and space tells matter how to move. This means you're not being pulled down by the Earth. You're sliding down a dent in the fabric of reality created by the planet's mass. Usually this dent is smooth, it is gentle, but if you put enough mass in one place, the dent becomes a hole, and if you keep adding mass, the hole becomes bottomless. This is the central terror of the black hole. It is a region where the fabric of reality has been punctured. Imagine stretching a rubber sheet until it snaps. A black hole is that snap. It is a point where the structural integrity of the universe has failed. And because the universe is everything there is, a failure in the universe is a failure in existence itself. For centuries, humanity refused to believe such a thing could be real. It was too monstrous. It was too absurd. In the late 18th century, a clergyman named John Michel calculated that if a star was massive enough, its gravity would be so strong that not even light could escape it. He called them dark stars. It was a mathematical curiosity, a ghost story for astronomers. But then, in 1915, Albert Einstein published his theory of general relativity. He gave us the equations that describe how matter warps the fabric of space-time, and hidden inside those equations was a demon. A few months later, a German physicist named Karl Schwarzschild, while fighting in the trenches of World War I, surrounded by the horrors of human warfare, found a solution to Einstein's equations that revealed a cosmic horror. He calculated what would happen if you took a mass and squeezed it down to a single point. The math revealed something impossible. It revealed a point of infinite density, surrounded by a barrier from which nothing could return. This was the Singularity. When Einstein saw the math, he rejected it. He didn't think the math was wrong. He thought the universe would never allow such a monstrosity to exist. He believed nature would have a fail-safe mechanism, a cosmic guardrail, to prevent a black hole from forming. The idea was too offensive to the laws of physics. It was an aberration. But Einstein was wrong. Nature does not care about our comfort. Nature does not care about logic. Nature does not care if the equations make sense to a primate brain evolved on the African savanna. In the decades that followed, we found them. We found Cygnus X1 sucking the life out of a companion star. We found the supermassive monster at the centre of our own galaxy, Sagittarius A star, swinging entire solar systems around it like toys. We took a picture of the shadow of the beast in M87, a ring of fire surrounding a heart of absolute darkness. We proved that the monsters are real, and now we are left with the terrifying implications of their existence. We are standing on the edge of a cliff, looking down into a pit that has no bottom, realizing that the pit is looking back at us. What we have found since then has spawned theories that make the original concept of a dark star look harmless. We have moved from simple astrophysics to high-octane nightmare fuel. The 7 theories we're about to discuss are not just guesses. They are the logical conclusions of our best science. They are what happens when you take the laws of physics and push them until they break. They challenge the stability of matter. They challenge the flow of time. They challenge the very idea that you are a real person living in a real universe. So, take a deep breath. Look at the room around you. Appreciate the light. Appreciate the structure. Because we are about to turn the lights off. We are about to step into the event horizon. Let's begin with the most immediate horror. The physical dismantling of the human form. The realization that your body is not a solid object, but a collection of particles held together by forces that are laughably weak compared to the monster waiting in the dark. This brings us to theory number 1, the tidal meat grinder. Before we subject the human body to the violent dismantling of the tidal forces, we must first understand the intellectual violence that the black hole inflicted on the human mind. Because the story of the black hole is not just a story of discovery, it is a story of denial. For nearly 200 years, the smartest primates on this planet fought desperately to prove that these monsters did not exist. We didn't want them to be real. The black hole was not a trophy we sought, it was a nightmare we tried to wake up from. It began innocently enough, in the mind of an 18th century English rector named John Michell. In 1783, he dared to ask a simple, dangerous question. What happens if you make a star so heavy and so dense that its escape velocity exceeds the speed of light? Newton's laws were clear. If you throw a stone up, gravity pulls it down. If you throw it fast enough, it escapes. Michell calculated that a star with the same density as the Sun, but 500 times larger, would have gravity so intense that not even light corpuscles could leave its surface. He called them dark stars. To him, they were invisible giants floating in the void. It was a neat mathematical trick, a curiosity. But Michell died before he could realize that he hadn't just predicted a heavy star. He had predicted the end of the known universe. The idea lay dormant for over a century, buried in the dusty archives of astronomy. It waited there, like a dormant virus, until 1915. That was the year Albert Einstein rewrote the operating system of reality. With general relativity, gravity was no longer a force, it was geometry. Space and time were a fabric, a flexible stage that curved and warped under the weight of matter. Einstein's equations were beautiful, they were elegant. They described a universe of smooth curves and predictable motions. Einstein believed in a universe of order. He famously said, "God does not play dice." He believed in a cosmos that made sense. But buried deep inside his own beautiful equations was a demon waiting to be released, and it took a man surrounded by death to find it. In 1916, the German physicist Karl Schwarzschild was stationed on the Russian front of World War I. He was not in a university library. He was in the trenches, surrounded by the roar of artillery, the smell of mustard gas, and the frozen mud of a dying continent. While calculating the trajectories of artillery shells, Schwarzschild began to play with Einstein's new equations. He wanted to solve them for the simplest possible case, a single, non-rotating spherical mass. What he found on that battlefield should have terrified him more than the war. He found that if you squeeze that mass into a small enough radius, a boundary now known as the Schwarzschild radius, the curvature of space-time didn't just bend, it snapped. The equations blew up. At the centre of this radius, the density became infinite, the volume became zero, and time itself stopped. Schwarzschild had mathematically proved the existence of a point where physics ceases to apply. He sent his solution to Einstein just months before he died of an autoimmune disease contracted in the trenches. He died thinking he had solved a math problem. He didn't know he had signed the death warrant for the concept of a safe universe. When Einstein read the letter, he was impressed by the math but horrified by the implication. He accepted the Schwarzschild singularity as a mathematical possibility, but he vehemently rejected it as a physical reality. He spent the next 20 years trying to prove that nature would never allow such an abomination to form. He argued that angular momentum or gas pressure or some unknown force would always stop a star from collapsing all the way down to a point. To Einstein, the singularity was an offence. It was irrational. It was a place where cause and effect broke down. If singularities existed, then the universe was not a clockwork mechanism. It was a chaotic system with holes in it. Einstein wasn't alone. The greatest minds of the 20th century joined the resistance. Arthur Eddington, the man who proved relativity, called the idea of a star collapsing to a point absurd. He famously said, "There should be a law of nature to prevent a star from behaving in this absurd way." Note the word should. That is the sound of human arrogance. We wanted the universe to behave. We wanted it to follow rules that made us feel comfortable. We treated the black hole like a mathematical ghost, something that lived on paper but could never manifest in the real world of atoms and starlight. But the math was relentless. In 1939, just as the world was plunging into a Second World War, J. Robert Oppenheimer, the man who would soon become the father of the atomic bomb, and his student Hartland Snyder published a paper that killed the denial. They calculated the collapse of a massive star that had run out of fuel. They stripped away the pressure, the rotation, and the heat. They asked the raw equations what would happen when the nuclear fire went out. The answer was silence. The star would not stop. It would not bounce. It would collapse past the neutron star stage, past the Schwarzschild radius, and keep falling inward forever, leaving behind a hole in the universe. Continued gravitational contraction. That was the clinical term they used. It was the birth certificate of the black hole. Yet, even then, the world ignored it. The war took precedence. Nuclear physics became about building bombs, not understanding gravity. The black hole was forgotten again, a dark secret locked in the basement of theoretical physics. It wasn't until the 1960s, the golden age of relativity, that the monster was finally given a name. John Wheeler, an American physicist, grew tired of saying gravitationally completely collapsed star. At a conference in 1967, he adopted a term suggested by an audience member, black hole. The name stuck because it was perfect. It wasn't scientific, it was visceral. It sounded like a void. It sounded like a threat. And suddenly, the hunt was on. In the 1970s, we found Cygnus X1. A massive blue star was being whipped around something invisible, something that was tearing chunks of gas off the star and heating them to millions of degrees until they screamed in X-rays. We couldn't see the object, but we could see its hunger. The ghost had become flesh. Einstein was wrong. Eddington was wrong. Nature did not have a law to prevent the absurd. Nature loved the absurd. Since then, we have realized that we are not living in a safe, static cosmos. We are living in a universe riddled with these traps. We now know that there is a supermassive black hole at the center of almost every galaxy, including our own. Sagittarius A star sits there, 26,000 light-years away, with the mass of 4 million suns, holding our galaxy together like a dark anchor. We know they collide, shaking the fabric of space-time with enough power to be heard 1 billion light-years away. We know they are real, but knowing they are real is not the same as understanding them. In fact, admitting they are real was just the beginning of the nightmare. Because once we accepted the black hole, we had to accept the paradoxes that came with it. We had to face the fact that our physics breaks at the event horizon. We had to face the fact that these objects defy the rules of time and information. The resistance of Einstein and Eddington wasn't just stubbornness, it was an intuitive fear. They sensed that if you let the black hole in, you let chaos in. And they were right. Now we're going to walk past the warning signs that Einstein tried to erect. We're going to cross the line that Eddington tried to erase. We're going to look at exactly what happens when the math stops working and the horror begins. We are done with the history of the mind. It is time to look at the destruction of the body. It is time to feed the monster. This brings us to the first level of the spiral, the physical reality of the descent. Theory number 1, the tidal meat grinder. Theory number 1, the tidal meat grinder. To understand the true horror of falling into a black hole, you have to forget everything you have seen in Hollywood movies. In the movies, the death is clean. The spaceship shakes a little, the alarm goes off, the pilot screams, and then everything fades to black in a split second. It is dramatic, but it is quick. It is a mercy kill. But physics tells us that the universe is not merciful. Physics tells us that death by a black hole is not a sudden event. It is a process. It is a slow motion, agonizing, industrial deconstruction of your biology known as spaghettification. It sounds like a joke, a silly word invented to explain complex math to children. But if you are the one falling in, it is the most violent thing that can happen to matter in the known universe. Let's run the simulation. Imagine you are an astronaut floating in deep space. You have drifted away from your ship. Your tether has snapped. You are drifting toward a stellar mass black hole, a monster with 10 times the mass of the Sun, squeezed into a sphere the size of Manhattan. This is important. A supermassive black hole, ironically, would kill you gently at first. But a small black hole is a concentrated razor blade of gravity. The smaller the hole, the steeper the gradient. The steeper the gradient, the more violent the death. The first thing that breaks your mind is not the pain, but the view. As you drift closer, the laws of optics begin to fail. You expect to see a black sphere blocking the stars, but a black hole is not a solid object. It is a lens. Its gravity is so intense that it grabs the light from the stars behind it and bends them into circles. You don't see a hole, you see a funhouse mirror of the universe. The stars behind the black hole are smeared into long, curved streaks of light called an Einstein ring. It creates a perfect, glowing halo around the darkness. It is hypnotizing. It is the most beautiful thing you have ever seen. But inside that ring, there is the shadow, the event horizon, the point of no return. It sits there like a drop of ink in a glass of water, absolutely still, absolutely silent. There is no sound in space, but looking at it, you feel a heavy silence in your bones. It is the silence of a predator that doesn't need to hunt because it knows you are coming to it. As you fall closer, the universe behind you begins to change. Because of your speed and the intense gravity, the light from the stars you came from is being shifted. The view behind you begins to shrink. The entire universe, the Milky Way, the distant galaxies, your spaceship, is compressed into a smaller and smaller circle of light behind your head. It is as if the universe is closing its eye. At the same time, the darkness in front of you grows. It fills your vision. Then you cross a specific mathematical boundary that exists nowhere else in nature. You cross the photon sphere. This is located at 1.5 times the Schwarzschild radius. This is the point where gravity is strong enough to trap light in a stable orbit. Think about what that means. Photons of light are orbiting the black hole like planets around a star. This creates a terrifying visual hallucination. If you were to turn your head to the side at this exact moment, you would see a ghost. You would see the back of your own head. Why? Because the light reflecting off the back of your helmet has travelled around the black hole, completed a full circle, and come back to hit your eyes. You're looking at yourself from the third-person perspective. You're trapped in a visual echo chamber. You're seeing your own past catching up to you. For a brief second, you're surrounded by images of yourself, a ring of ghosts orbiting the drain. It is the ultimate dissociation. You're no longer just an observer of the universe, you're observing your own demise from the outside. But the visual trip ends quickly, because now the sensation begins. This is where the tidal in tidal forces comes into play. We call them tidal forces because it is the same mechanism that causes the tides on Earth. The moon pulls on the ocean on the side of the Earth facing it more than it pulls on the ocean on the far side. That difference stretches the water, creating high tides. But the moon is far away, and its gravity is weak. The black hole is right next to you, and its gravity is infinite. Gravity obeys the inverse square law. If you halve the distance to the source, the gravity becomes 4 times stronger. As you approach the black hole, this math stops being abstract and starts being torture. You're falling feet first. Your feet are slightly closer to the singularity than your head, maybe by only 6 feet. On Earth, a 6-foot difference means nothing, but here, the gravity at your feet is millions of times stronger than the gravity at your head. The universe grabs your boots and pulls, hard. At the same time, because you are falling along radial lines that converge at the centre, the sides of your body are being squeezed inward. Imagine being put on a medieval rack. You feel your ankles pop, then your knees. The connective tissue in your hips begins to groan under the strain. You are being stretched vertically and crushed horizontally. You're being turned into a tube of toothpaste. This is the spaghettification process beginning. But it's not just your joints, it's your blood. The fluid in your legs is being pulled down so hard it cannot pump back up to your heart. You begin to red out. Your vision blurs, but you don't pass out. The adrenaline keeps you awake for the horror. You feel your muscles tearing away from the bone. You feel the skin on your chest tightening until it splits. The benevolent hand of gravity has turned into a fist, and it is squeezing the humanity out of you. And the worst part? To the rest of the universe, you are frozen. If your crewmates were watching you from the spaceship, they would not see you fall in. As you get closer to the horizon, the light coming from your body has to fight harder to escape the gravity well. It loses energy, its wavelength stretches. You turn red, then infrared, then radio waves. To the outside observer, time slows down for you. They see you slowing down, dimmer and dimmer, frozen forever just above the edge of darkness. You become a permanent ghostly statue on the horizon, a warning sign for future travellers. But that is their perspective. In your frame of reference, time is flowing normally. You don't freeze, you don't stop, you keep falling. The pain doesn't pause, you plunge through the event horizon, the point of no return. You're now leaving the observable universe, you're exiting the map. And this is where the meat grinder shifts gears from biological torture to atomic annihilation. Because now, the gravity is strong enough to overcome the forces that hold your molecules together. This leads us to the second half of the physical nightmare, the moment where you cease to be a solid object and become a stream of data. We left you hanging in the void, your body stretched into a grotesque, elongated shape by the tidal forces. But the torture is just getting started. As you plummet closer to the event horizon, the gravity gradient becomes so steep that it stops attacking your anatomy and starts attacking your chemistry. The forces holding your body together are electromagnetic. Your cells are glued together by proteins. Your DNA is a ladder held together by chemical bonds. These forces are strong, but they are finite. The tidal forces of a small black hole are infinite. There comes a specific millisecond where the gravitational difference between the top of a molecule and the bottom of a molecule exceeds the strength of the chemical bond holding it together. Snap. In an instant, the intricate machinery of your biology dissolves. You don't just die, you unzip. Your skin, your organs, your bones. They don't rot or burn. They simply cease to be solid. You're reduced to a soup of organic compounds, a mist of carbon, hydrogen, and oxygen falling in parallel lines. But the gravity isn't done. It wants more. It reaches inside the atoms themselves. Electrons orbit the nucleus of an atom in a cloud. They are held there by electromagnetism. But as the tidal force ramps up, it rips the electrons away from their protons. You are no longer human. You are no longer even chemical. You're a stream of superheated plasma, a line of ionized particles glowing white hot as they accelerate to near light speed. This is the final form of spaghettification. You're a single-file line of subatomic particles, miles long and 1 atom wide, screaming silently into the dark. This is the physical reality of the meat grinder. It is the ultimate cleaning service. It takes the complex, ordered information of a human being and scrubs it down to raw, chaotic energy. But while your physical form has been obliterated, something even stranger is happening to your image. This brings us to the most mind-bending aspect of the black hole, the time paradox. If you had a twin brother watching this nightmare from the safety of the spaceship, he would report a completely different story. He would not see you rip apart. He would not see you cross the horizon. In fact, he would swear on his life that you never fell in at all. This is due to gravitational time dilation. Einstein taught us that gravity drags on time just like it drags on space. The stronger the gravity, the slower time moves. As you get closer to the black hole, time for you, relative to the outside world, begins to crawl. To your brother, your fall begins to slow down. It looks like a video buffering. You wave your hand, and it takes an hour to complete the motion. You scream, and the sound is stretched into a low, eternal drone. As you reach the very edge of the event horizon, the boundary of no return, the effect becomes infinite. To the outside observer, time at the horizon stops. Your brother sees you freeze. You are suspended there, like a fly trapped in amber. You never cross the line. You are plastered against the false sky of the black hole, an eternal monument to your own death. And as he watches, the light coming from your frozen body struggles to climb out of the gravity well. It loses energy. The image of you turns red, then deep infrared. Then, slowly, over thousands of years, you fade into a radio ghost, a faint whisper of static that hangs on the edge of the abyss forever. Think about the horror of that duality. In the history of the universe, you are immortal. Your image is burned onto the skin of the black hole until the end of time. Future civilizations could fly by 1 billion years from now and detect the faint red-shifted signal of your scream. You are a permanent scar on the fabric of space. But that is the outside perspective. What about your perspective? This is where the trap snaps shut. You don't freeze, you don't slow down, you don't see yourself turning red. In your frame of reference, you fall right through the horizon without a bump. You look at your watch, the second hand is ticking normally. You look back at the universe, you see the stars, but you have crossed a line that marks the end of your causality. Once you're inside the horizon, space and time swap roles. This is not a metaphor. In our world, you can move freely in space, left, right, up, down, but you are forced to move forward in time. You cannot stop time. You cannot go back to yesterday. Inside a black hole, the geometry flips. The radial direction, the path toward the center, becomes time. The singularity is no longer a place in the center of the sphere. It is a moment in your future. Trying to avoid hitting the singularity inside a black hole is like trying to avoid next Tuesday. You can fire your rockets, you can struggle, you can cry. It doesn't matter. All paths, all futures lead to the center. Every direction you turn is down. The singularity is not in front of you, it is in your future. And just like you cannot stop the flow of time leading to your death on Earth, you cannot stop the flow of space leading to your annihilation at the center. You're now in a region of the universe that is causally disconnected from the rest of reality. You could scream, "I'm alive," into your radio, but the radio waves are trapped just like you. They will fall back down into the center. No signal can ever leave. You're alone in a way that no human being has ever been alone. You're in a private universe that is shrinking around you at the speed of a light. And this is just the physical death, the crushing of the body and the trapping of the soul. It assumes you had to travel to a black hole to find one. It assumes you had to be unlucky enough to fall into a known monster like Cygnus X1. But what if you didn't have to travel? What if the monsters are not sitting still? What if they are hunting? We comfort ourselves with the idea that space is empty and black holes are rare, distant giants. We map them. We point to them on charts and say, "There is the danger, stay away." But a new theory suggests that our maps are useless. It suggests that the darkness between the stars is not empty. It is teeming with invisible minds. Minds that don't wait for you to come to them. They come to you. This brings us to the second level of the spiral, the paranoia of the void. Theory number 2, the invisible stalkers. We usually comfort ourselves with the idea that space is empty. We look at the night sky and see vast stretches of nothingness between the stars. We treat the solar system like a gated community. The sun is the warm fire in the centre, the planets move in predictable, safe clockwork orbits, and the monsters, the black holes, the supernovas, the gamma-ray bursts, are kept far away, locked in the bad neighbourhoods of the galaxy. We assume that to die by a black hole, you have to be stupid enough to fly a spaceship right next to one. We assume that if a black hole were near us, we would know about it. It would be a giant gaping maw in the sky, consuming light and screaming in X-rays. But this assumption relies on a single fragile premise, that all black holes are formed by dying stars. If a black hole is born from a star, it has to be massive. It has to be at least 3 times the mass of the Sun. It is a giant. You can't miss a giant. But what if there is another breed of monster? What if the universe is infested with black holes that were never stars? What if they are as common as asteroids, but invisible to every telescope we possess? This brings us to theory number 2, the invisible stalkers. To understand this threat, we have to go back to the beginning. Before there were stars, before there were galaxies, before there were atoms. We have to go back to the first fraction of a second after the Big Bang. Standard cosmology tells us that the early universe was a hot, dense soup of energy. It was expanding rapidly, but it wasn't perfectly smooth. There were fluctuations, tiny ripples in the density of the plasma. Imagine a pot of boiling water. It's chaotic. Some bubbles are bigger than others. In the violent, high-energy environment of the early universe, some of these pockets of matter were slightly denser than their neighbours, just slightly. But in a universe that dense, slightly is enough. Gravity took hold of these pockets. Because the pressure was so immense, these pockets didn't just clump together to form stars, they collapsed instantly. They were crushed by the weight of the universe around them before they could even shine. These are called Primordial Black Holes, PBHs. And here is why they are terrifying. They don't follow the rules of stellar evolution. A stellar black hole has a size limit. It has to be big. A primordial black hole can be any size. It depends entirely on when it formed. If it formed 1 second after the Big Bang, it might be massive. But if it formed a split second earlier, it could be the size of a mountain. If it formed even earlier, it could be the size of a grain of sand or a single atom. Think about the implications of that. Standard physics says black holes are rare giants. Primordial black hole theory says they are cosmic shrapnel. They are the debris left over from the explosion of creation. And just like shrapnel, they could be everywhere. For decades, this was just a theory on paper, proposed by Stephen Hawking and Bernard Carr in the 1970s. But recently, the idea has come roaring back to life, fueled by a mystery that has haunted astronomy for 50 years: dark matter. We know that 85% of the matter in the universe is invisible. It has gravity, it holds galaxies together, but it doesn't interact with light. We have spent billions of dollars building underground detectors to find dark matter particles, but we have found absolutely nothing. The silence is deafening. This has led a growing number of terrified cosmologists to a chilling conclusion. What if dark matter isn't a particle? What if dark matter is just billions upon billions of primordial black holes swarming through the galaxy? If this hypothesis is true, the Milky Way is not mostly empty space. It is a minefield. It means that for every visible star you see in the sky, there could be thousands of tiny invisible black holes buzzing around it. And when we say tiny, do not make the mistake of thinking weak. A primordial black hole the size of a tennis ball would have the mass of the entire Earth. Let that sink in. The entire weight of our planet, every mountain, every ocean, every city, crushed into something you could hold in your hand. If such an object were floating in space, how would you see it? You wouldn't. It's too small to block starlight. It doesn't have a massive accretion disk of glowing gas because it's too small to catch much matter. It is a stealth object. It is a ghost. These objects would be wandering through the galaxy, untethered to any star system. They are rogue agents. They drift through the interstellar void at hundreds of thousands of miles per hour. And statistically, given the sheer number of them required to explain dark matter, it is inevitable that they pass through solar systems. They might have passed through ours already. Some astronomers have analysed the orbits of the objects in the Kuiper belt, the ring of icy rocks past Pluto, and found strange anomalies. The rocks are moving in ways that suggest something heavy disturbed them long ago. Something invisible, something fast. It is entirely possible that a primordial black hole punched a hole through the outer solar system 1 million years ago and kept going. But the horror isn't in what happened in the past. The horror is what happens if one arrives tomorrow. Unlike the stellar black hole, which sits in one place and waits for you to fall in, the primordial black hole is a bullet. It moves, and because it is invisible, we have no early warning system. We wouldn't see it coming until the gravity started to tear things apart. We rely on the stability of our solar system. We trust that the Earth orbits the Sun in a perfect circle, keeping us in the Goldilocks zone, not too hot, not too cold. But that stability is a delicate balance of gravitational vectors. It works because the Sun is the only heavy thing in the room. If you introduce a rogue intruder, a marble-sized object with the mass of Jupiter, or a bowling ball-sized object with the mass of 10 Earths, that balance shatters. It doesn't even need to hit us. A collision would be instant death, yes, but a flyby is a slower, colder execution. Imagine a primordial black hole passing through the inner solar system, passing between Mars and Earth. It wouldn't look like much. You might see a tiny distortion in the stars, a momentary wiggle in the constellations, but the ground beneath your feet would feel it. The tides would surge violently, not just in the ocean, but in the crust of the Earth, triggering global earthquakes and volcanic eruptions instantly. But the real threat is orbital. The gravity of the intruder would tug on the Earth. It would yank us sideways. It would impart a gravitational kick, and in orbital mechanics, a kick changes everything. This brings us to the rogue scenario, the nightmare of being evicted from our own home. Theory number 2, part 2, the eviction. We tend to think of the Earth's orbit as a permanent track, a steel rail welded into the fabric of space. We assume we are locked to the Sun forever, but in celestial mechanics there is no such thing as forever. Orbits are just a balancing act between momentum trying to fly away and gravity trying to pull in. It is a delicate handshake, and a primordial black hole is the thing that breaks the fingers. If a rogue black hole with the mass of Jupiter passed through our neighbourhood, it wouldn't need to collide with us to kill us. It would simply need to pass close enough to engage in a gravitational tug-of-war with the Sun. For a few weeks, the Earth would be caught between two masters. The chaotic gravitational waves would trigger tsunamis a mile high. The crust would flex and crack, levelling cities with magnitude 10 earthquakes. But the real end comes when the intruder leaves. As the black hole exits the solar system, it drags us with it. It acts like a gravitational slingshot. It imparts just enough energy to the Earth to sever the Sun's grip. We reach escape velocity. This is the ejection scenario. It is not a violent explosion. It is a silent uncoupling. We would simply drift away from the fire. Imagine the timeline of this apocalypse. It is slow. It is psychological torture on a planetary scale. In the first week, you wouldn't notice much difference in the sky. But astronomers would be screaming. They would see the math. They would know the contract with the Sun has been cancelled. By the second month, the change becomes visible to the naked eye. The Sun, which has been a constant size in our sky for 4 billion years, begins to shrink. It becomes smaller, paler, more distant. The temperature begins to drop. At first, it feels like a harsh winter, but winter never ends. The tropical zones freeze over. The crops die worldwide. The global food chain collapses in weeks. As we cross the orbit of Mars, the oceans begin to freeze. Not just the surface, but deep down. A shell of ice miles thick encases the planet, sealing the darkness below. As we cross the orbit of Pluto, the Sun is just a particularly bright star in the distance. It offers no heat. The temperature on the surface plummets toward absolute zero. The atmosphere itself begins to fail. The air you breathe turns into liquid. It rains liquid nitrogen and oxygen, pooling in neon blue lakes on top of the ice. Then, as the heat leaves the core, the air freezes into solid blocks of nitrogen snow. The sky turns perfectly clear and perfectly black. The blue dome is gone. You can see the stars at noon, but there is no one left to look at them. The Earth has become a rogue planet, a Steppenwolf. We are now drifting alone in the interstellar void, a frozen tomb carrying the ruins of human civilization into the dark. We will drift like this for trillions of years, completely preserved in the vacuum, a museum of dead things waiting for an alien archaeologist to find us. This is the fate of a planet that meets an invisible stalker. But there is a variation of this theory that is arguably terrifying in a different way. The ejection assumes the black hole is heavy. Masses of Jupiter or Earth, But remember, primordial black holes can be tiny. They can be the size of an atom. What happens if a microscopic black hole doesn't just pass by, but hits us directly? This is the cosmic bullet hypothesis. If a black hole with the mass of an asteroid but the size of a proton hits the Earth, it won't swallow the planet. It is moving too fast. It hits the atmosphere at 200,000 miles per hour. It punches a hole through the air, creating a sonic boom that could shatter windows across a continent. Then it hits the ground. Because it is so small and heavy, it doesn't stop. It passes through the crust, the mantle, and the core of the Earth like a needle through a cloud. It creates a tunnel of superheated plasma, vaporizing rock instantly as it bores through the planet. It exits the other side of the Earth seconds later and shoots back out into space. Did it kill us? Maybe not instantly, but it left a wound. As it passed through the core, it would generate a shockwave of seismic energy. Some geologists have looked at unexplained seismic events, earthquakes that happen in places where there are no fault lines, and wondered, did we get shot? There is even a fringe theory among some physicists that the Tunguska event in 1908, a massive explosion in Siberia that flattened 800 square miles of forest with no impact crater, was not a meteor, but a tiny primordial black hole passing through the Earth. If it had been a meteor, where are the fragments? If it was a black hole, it exited over the Atlantic Ocean and is now light years away. We survived the bullet, but we didn't see the gun. This theory transforms the ground beneath your feet into a target. We are sitting ducks in a galactic shooting gallery, waiting for a bullet we cannot see, fired from the Big Bang 13.8 billion years ago. It tells us that our safety is purely statistical. We are alive simply because the void is big and the bullets are small. It is not safety, it is luck. But let's pause. Let's assume we are lucky. Let's assume the vacuum is empty of monsters. Let's assume gravity doesn't crush us and rogue black holes don't evict us. We are safe in our bodies. We are safe in our orbit. But are we safe in our past? The next spiral of the distortion takes us away from physical threats and into logical threats. It attacks something more fundamental than your life. It attacks your history. Science is built on the idea that the past determines the future. If you know the present, you can reconstruct the past. But black holes have a secret. They are the ultimate sensors. They eat information, and if they eat information, then the past is not written in stone. It is being erased. This brings us to theory number 3, the Great Eraser. The paradox that broke Stephen Hawking's heart and threatens to break physics itself. We have spent the last hour discussing how black holes destroy matter. We have talked about how they rip apart bones with tidal forces and how they could eject our planet into the dark. These are terrifying scenarios, but they are, in a sense, simple. They are just acts of violence. A hurricane destroys a house, a bomb destroys a city, a black hole destroys a solar system. Violence is something we understand. It fits into our model of the world. Things die, things break, but there is a deeper form of destruction. A destruction that doesn't just attack the things inside the universe, but attacks the rules of the universe itself. This brings us to the third spiral of the distortion. The most famous and most disturbing problem in theoretical physics, the information paradox. To understand why this is a nightmare, we first have to understand the most sacred rule of science. It is called determinism, or in quantum mechanics, unitarity. The rule is simple: the universe never forgets. Imagine you take a dictionary. You rip out every page, you shred the pages into confetti, then you set the confetti on fire. You take the ash and mix it into water. To you, the information in that dictionary is gone. You can no longer read the definition of entropy. But to a physicist, the information is not gone. It is just scrambled. If you had a supercomputer capable of tracking every single photon of light from the fire, every single molecule of carbon in the ash, and every atom in the water, you could theoretically reverse the process. You could run the movie backward. You could reconstruct the dictionary page by page. This is the bedrock of physics. The past determines the present. Therefore, if you know the present perfectly, you can reconstruct the past. Information is conserved. It changes form, it spreads out, it becomes messy, but it is never ever deleted. This rule allows us to predict the orbits of planets and the behavior of atoms. It tells us that cause and effect are real. It tells us that history is a solid line that stretches back to the Big Bang. For a long time, we thought black holes obeyed this rule. We thought they were cosmic vaults. If you threw a dictionary into a black hole, we assumed the dictionary was safe inside. Sure, it was crushed to a singularity, and we couldn't read it anymore because light couldn't escape to tell us what it said. But we comforted ourselves with the idea that the book was still there, locked in the dark, preserving the continuity of reality. The information was hidden, not lost. But in 1974, a young physicist named Stephen Hawking walked into the room and broke the vault open. Hawking applied quantum mechanics to the edge of the black hole, the event horizon. He discovered something that shocked the scientific community. He found that black holes are not truly black. They glow. In the vacuum of space, empty space is not empty. It is seething with quantum activity. Pairs of virtual particles are constantly popping into existence and annihilating each other. A particle and an antiparticle appear, borrow energy from the vacuum, snap together and vanish. It happens everywhere, all the time. It is the quantum foam. Usually this doesn't matter, but Hawking realised that if this happens right on the edge of a black hole, something catastrophic occurs to the logic of the universe. Imagine a pair of particles pops into existence right on the razor's edge of the horizon. One particle is on the safe side, the other is on the dangerous side. The particle on the inside gets captured, it falls in. The particle on the outside escapes, the pair has been separated. They cannot annihilate each other. The particle that escaped becomes real radiation. We see it as a faint glow. This is Hawking radiation. But here is the kicker. Nature balances its books. You cannot create energy from nothing. If the escaping particle has positive energy, which it must to exist, then the particle that fell in must have negative energy to balance the debt. When the black hole swallows this negative energy particle, it loses mass. Let that sink in. The black hole is eating negative energy. This means that as it radiates, the black hole shrinks. It gets smaller and smaller and smaller. It is leaking its mass into the universe as heat. It is evaporating. If you wait long enough, trillions upon trillions of years, the black hole will eventually disappear completely. It will vanish in a final puff of gamma rays, and this is the moment the trap snaps shut. This is the Great Eraser. Let's go back to our dictionary. You threw it into the black hole 1 billion years ago. It contained specific information, words, definitions, the arrangement of ink on paper. That information fell in. But now the black hole has evaporated. It is gone. All that is left is the Hawking radiation that leaked out over the eons. Here is the horror. Hawking's calculations showed that the radiation is thermal. It is random. It is heat. It carries no information about what fell in. It doesn't matter if you threw in a dictionary, a catastrophic virus, or a golden retriever. The radiation that comes out is exactly the same. It is featureless static. So the black hole is gone, the dictionary is gone, and the radiation doesn't have the dictionary encoded in it. Where did the information go? It didn't just get scrambled like the burning book. It vanished. It was deleted from the universe. This is a violation of unitarity. It implies that the universe is not a movie that can be played backward. If you look at the radiation left behind, you cannot reconstruct the star that made the black hole. You cannot reconstruct the civilizations it swallowed. The causal link between the past and the future has been severed. This is not just a missing book. This is a lobotomy of reality. If Hawking is right, then the universe is fundamentally unpredictable. It means that the laws of physics are not constant. It implies that history is not real. If information can be destroyed, then what happened is not a fixed fact. It suggests that we are living in a reality that is constantly erasing its own memory tracks. This realization sent a wave of panic through the physics community that hasn't subsided in 50 years. It started the black hole war between Stephen Hawking and Leonard Susskind. Hawking argued that the information was truly lost, that the black hole was a cosmic eraser. Susskind argued that this was impossible, because if information is lost, energy conservation breaks, and if energy conservation breaks, the entire mathematical framework of reality collapses. We are left with two terrifying options, and neither of them allows you to sleep soundly. Option A. Information is lost. The past is an illusion. The universe is a leaky bucket, and history is constantly dripping out of the hole, never to be recovered. We are living in a chaotic system where cause and effect are not guaranteed. Option B. The information is saved, but to save it we have to accept something even crazier. We have to accept that the dictionary is in two places at once. We have to accept that the 3D world is a lie. This paradox forces us to choose between the sanity of time or the sanity of space. Most physicists today believe the information is saved, but the price we have to pay to save it is the subject of the next part of our spiral. To save the library, we have to burn the library, although we have to realize that the library never existed in 3D space at all. This brings us to the firewall paradox and the holographic principle. Theories that suggest the event horizon is not a door but a projector screen, and you are just a pixel. We have established the crime scene. The black hole is evaporating. It is bleeding energy into the void in the form of Hawking radiation, and eventually it vanishes, taking everything it ever swallowed with it. But we need to truly understand the victim of this crime. The victim is not the matter. It is not the light. The victim is the past. To understand why this terrifies physicists, you have to understand how they view the universe. To a physicist, the universe is not a collection of things. It is a collection of states. It is a four-dimensional block of data. Every particle, every spin, every position is a bit of information. And the fundamental law of quantum mechanics, unitarity, says that this data is indestructible. Think of reality like a movie reel. The present moment is a single frame. The laws of physics are the projector. If you play the movie forward, you get the future. But crucially, because the laws of physics are symmetric, if you play the movie backward, you should get the past. You should be able to look at the scattered ash of a burnt letter and mathematically rewind the fire to see the ink on the paper. The universe holds the memory of the letter in the arrangement of the ash. It is difficult to read, yes, but it is not deleted. The memory is physically encoded in the atoms. This concept, that the past is locked into the present, is what makes history real. It is what makes you real. You are the sum of your memories and your biological history. You exist because a specific chain of events led to this moment. But Hawking's calculation suggests that black holes are cosmic shredders that don't just cut the paper, they incinerate the atoms of the paper and then delete the memory of the atoms. When a black hole evaporates via Hawking radiation, the radiation is thermal. This is a physics term that means random. It is featureless static. It carries no pattern. It carries no imprint of the star that collapsed, or the planets it ate, or the light it trapped. It is just heat. So, let's run the scenario. You throw a hard drive containing the sum of human knowledge into a black hole. It falls in. 1 trillion years later, the black hole evaporates into a cloud of random heat. If you look at that heat, you cannot reconstruct the hard drive. The data is not scrambled, it is gone. This means the movie cannot be rewound. The link between the future and the past has been severed. This is the information loss scenario, and if it is true, the implications are catastrophic for our understanding of reality. It implies that the universe has amnesia. It implies that history is not a solid foundation, but a temporary hallucination that is constantly being eroded at the edges. If information can be lost in a black hole, why can't it be lost everywhere? If the laws of physics allow for the deletion of the past in one place, the integrity of the entire system is compromised. It suggests that there is no objective reality of what happened yesterday. Yesterday is just a probable guess. This realization sparked a 30-year intellectual civil war in physics, known as the Black Hole War. On one side was Stephen Hawking, the nihilist of the group, who argued that we just have to accept it. The universe is unpredictable. God not only plays dice, but he throws them where they cannot be seen. Hawking was willing to sacrifice the permanence of the past to save the logic of the black hole. On the other side was Leonard Susskind and Gerard Tufte. They were the defenders of memory. They argued that if information is truly lost, then energy conservation breaks. And if energy conservation breaks, the vacuum of space should be unstable. The universe should burn up instantly. They argued that saving the past was worth any price, even if the price was abandoning common sense. Susskind realized that to save the information, to ensure that the movie could be rewound, the information had to escape the black hole. It couldn't be deleted. It had to be returned to the universe. But how? Nothing can escape the event horizon. That is the definition of a black hole. To say the information gets out is like saying a prisoner escaped a maximum security cell without opening the door or digging a tunnel. It seems impossible, unless the prisoner never actually entered the cell. This is the turning point where the horror shifts from loss of history to illusion of reality. Susskind proposed a radical solution. He suggested that when an object falls into a black hole, it doesn't just pass through the horizon. He argued that from the perspective of an outside observer, the information contained in the object gets plastered onto the surface of the horizon. Imagine throwing a book into a vat of acid. The book dissolves. But imagine if, instead of dissolving, the ink from the pages floated to the surface of the acid and formed a film. The book is destroyed, but the words are still there, floating on the outside. Susskind argued that the event horizon is not empty space. It is a complex, scrambled ocean of bits. Every single thing the black hole has ever eaten is stored as data on its surface. It is a shell of information. And when Hawking radiation leaves the black hole, it picks up this data. It encodes the information from the surface and carries it back out into the universe. The hard drive is not destroyed. It is scrambled, turned into heat, and radiated back out. The library burns down, but the smoke contains the text of every book. The universe remembers. We are saved. Determinism is rescued. The past is real. But wait, there is a problem. A massive, glaring logical contradiction that breaks the world even harder than information loss. If Susskind is right, the information is stuck on the surface of the black hole. But according to Einstein's general relativity, the theory that predicted black holes in the first place, the event horizon is not a solid wall. It is empty space. If you fall in, you shouldn't feel anything special until you hit the singularity. You should drift right through the horizon with your information intact. So, here is the paradox. According to quantum mechanics, Susskind, the information must stay on the surface to be radiated out. It cannot enter the hole, or it would be lost forever when the hole evaporates. According to general relativity, Einstein, the information must fall into the hole with you because space is smooth and gravity pulls you in. This means the information is in two places at once. It is plastered on the outside and it is falling on the inside. This is a direct violation of the no-cloning theorem of quantum mechanics. You cannot make a perfect copy of quantum information. It's illegal in the laws of physics. You cannot have the hard drive safe on the outside and falling on the inside at the same time. One of them has to be fake. This is the deadlock. We are stuck between a rock and a hard place. If Hawking is right, the past is deleted and history is a lie. If Susskind is right, we have to explain how an object can be in two places at once without breaking reality. The attempt to solve this paradox led to the creation of a monster, a theory that suggests that the smooth, safe, empty space we think we're falling through is actually a lie generated by a hologram. It suggests that the 3D world is a projection of a 2D surface. To save the memory of the universe, physicists had to destroy the concept of place. They had to propose that inside and outside are not real physical distinctions, and this leads us to the fourth spiral of distortion. The moment where we realize that the black hole might not be a hole at all. It might be a solid wall of fire or a hard drive pretending to be a universe. This brings us to theory number 4, the firewall and the holographic trap. We're standing at the edge of a precipice. On one side we have general relativity, which tells us the black hole is a smooth, empty pit. On the other side we have quantum mechanics, which tells us the black hole must save the information of everything it eats. And in the middle we have the information paradox, a logical bomb that threatens to destroy our understanding of time itself. So how do physicists sleep at night? They try to find solutions, but the solutions to this paradox are arguably more terrifying than the problem itself. They don't just fix the math, they rewrite the nature of reality in ways that sound like madness. Let's look at the first possibility. The past never existed. This is the solution if Stephen Hawking was right in his original 1974 claim. If information is truly destroyed, it means that the universe is not unitary. It means the movie of reality cannot be rewound. Think about what this does to the concept of history. We assume the past is a solid thing. We assume that the Roman Empire existed, that dinosaurs walked the earth, that you were born on a specific day. We believe this because we see the evidence in the present. We see ruins, fossils, and birth certificates. We assume these traces were caused by the past events. But if the universe allows information to be deleted, then the link between cause and trace is broken. If a black hole can delete a star, it cuts the causal chain. And if the chain is cut anywhere, it cannot be trusted everywhere. In a non-unitary universe, the past is not a fixed place. It is just a probability cloud. It means that your memories are not records of events that actually happened. They are just chemical states in your brain. that exist right now. There is no guarantee that they were put there by experience. In a universe that leaks information, you cannot prove that the universe didn't start 5 minutes ago, complete with false memories of a life you never lived. This is the last Thursdayism nightmare made physical. If black holes are erasing the tape of history, then we are living in a reality that is constantly forgetting how it got here. We are characters in a book where the previous chapters are being torn out as we read them. We have no origin, we have no legacy, we just are, floating in a disconnected present. But most physicists hate this idea. They cling to the belief that the past is real. So they propose a second solution, a solution that saves the past but exiles it. Solution number 2, the baby universe. Imagine the singularity at the centre of the black hole. It is a point of infinite density. Some theories, like Einstein-Cartan gravity, suggest that the singularity doesn't crush matter into nothingness. Instead, it punches a hole through the fabric of space-time and opens up on the other side. Where is the other side? It is not in our universe. It is a new expanding bubble of space-time, a baby universe. According to this theory, everything that falls into a black hole, the light, the matter, the information, passes through the wormhole and becomes the big bang of a new reality. The information isn't lost, it just moved. It immigrated. This sounds beautiful. It sounds hopeful. We are the parents of new cosmos. But look at the horror hidden in the details. If the information goes into a baby universe, it is still lost to us. The connection is severed. The wormhole closes or becomes impassable. To us, the black hole still evaporates. To us, the book is still gone. We are left alone in our dying universe, while our children, the baby universes, expand away from us into dimensions we can never touch. It is a form of cosmic reproduction where the parent dies and never sees the child. It implies that our universe is just a placenta, a disposable casing designed to birth other realities before dissolving into entropy. We are not the point of existence, we are the waste product of the process. But there is a third solution, a solution that tries to keep the information right here, in our universe. But to do it, it requires a magical object that defies all logic. Solution number 3, the remnant. Recall that the black hole evaporates because of Hawking radiation. It gets smaller and smaller. Eventually it reaches the Planck scale, the smallest possible size in physics. It is a microscopic speck, smaller than a proton. Usually we assume it pops and vanishes, but the remnant theory suggests that the evaporation stops. The black hole stops shrinking. It becomes a stable, microscopic nugget. A remnant. Here is the crazy part. In order to solve the paradox, this tiny nugget, smaller than an atom, must contain all the information that ever fell into the black hole. If a black hole started with the mass of 1 billion suns and swallowed thousands of civilizations and then evaporated down to a speck, that speck must still hold the data of those billion suns. It is like trying to store the entire internet on a single electron. This implies that space has infinite storage capacity. It suggests that the universe is full of these heavy, silent ghosts. These remnants would be drifting everywhere, invisible, heavy with the memories of dead stars. We would be walking through a graveyard of information every day. The air around you would be filled with the compressed, frozen data of eons past, locked in cages too small to see. It turns the universe into a haunted attic, filled with dusty boxes that can never be opened. But recently, in just the last 5 years, physicists have found a fourth path. A solution that uses the most advanced math humanity has ever produced, the page curve and replica wormholes. I won't bore you with the calculus, I will tell you the implication. The new calculations suggest that the information does get out. The black hole eventually burps it back up. The past is saved, history is real, but the price is non-locality. To make the math work, physicists have to assume that the inside of the black hole and the radiation far away are somehow connected. Not connected by a tunnel, but connected by identity. They are the same thing. It means that space is an illusion. It means that here and there are not absolute concepts. If you fall into a black hole and your information is radiated out 1 billion miles away, the math treats those two locations as the same point. This destroys the concept of location. It suggests that the universe is not a vast 3D space. It is a massive web of entangled connections where distance is a lie. You're not on Earth. You're just a cluster of data that feels like it is on Earth, but you're quantum entangled with parts of the universe billions of light years away. If you touch your face, you're touching a specific set of atoms. But if non-locality is the solution to the black hole, then those atoms might be intimately connected to a black hole in Andromeda. The separation between you and the monster is a mirage. We saved the past, but we killed space. And this brings us to the inevitable climax of this conflict. The physicists realized that if they wanted to get the information out of the black hole before it evaporates, they had to break one of Einstein's favorite rules. They had to turn the event horizon from a smooth, empty boundary into something solid, something violent. They realized that the only way to verify the data is to burn the observer. This leads us to the most violent theory in modern physics, a theory that suggests that if you tried to fall into a black hole, you wouldn't survive the fall. You wouldn't even make it to the spaghettification. You would hit a wall of pure energy. This brings us to the fourth level of the spiral, the realization that the black hole might be a hologram and the horizon might be a furnace. Theory number 4, the firewall. We have arrived at the fourth spiral, the point where the cure becomes worse than the disease. To solve the information paradox, to ensure that the universe remembers its past, physicists were forced to construct a theory that burns down the house of Albert Einstein. For 100 years, the one thing we thought we knew for sure about black holes was that the event horizon is not a solid surface. It is a mathematical line. It is like the horizon on the ocean. If you sail toward the horizon, you don't bump into a line drawn on the water, you just pass through it. Einstein called this the equivalence principle. It was his happiest thought. He realized that a person falling freely in gravity feels exactly the same as a person floating in deep space. If you closed your eyes while falling into a huge black hole, you shouldn't feel anything. No bumps, no wind, just perfect weightless silence until you get deep inside and the tidal forces rip you apart. The horizon itself should be drama-free, but in 2012, 4 physicists, Almhiri, Marolf, Polchinski and Sully, known collectively as AMPS, did the math on the information paradox, and they found a contradiction that shattered Einstein's happy thought. They looked at the entanglement required to save the information. Remember, for the universe to be safe, unitary, the information must get out via Hawking radiation. This means the particle just outside the horizon, let's call it particle B, must be quantumly entangled with the radiation that escaped long ago, particle A. They are a couple. They share a secret code. This link is what carries the information away. But here is the problem. General relativity demands that space is smooth at the horizon. For space to be smooth, the particle just outside the horizon, particle B, must be entangled with its partner just inside the horizon, particle C. They have to be linked to ensure that space continues seamlessly across the boundary. So particle B has a problem. To save quantum mechanics, information, it must be married to particle A, far away. To save gravity, smooth space, it must be married to particle C, inside. But quantum mechanics has a strict rule called the monogamy of entanglement. A particle can only be fully entangled with one other particle at a time. It cannot be a bigamist. It cannot have a strong link to both A and C. It has to choose. If it chooses C, the inside particle, then the link to A is broken. Information is lost. History is deleted. We are back to the nightmare of Theory 3. But if it chooses A, the faraway radiation, which most physicists believe it must, to save the logic of the universe, then the link to C must be broken. And this is where the violence happens. In quantum field theory, you cannot just snap an entanglement link for free. Entanglement is what knits space together. It is the thread of the fabric. If you cut the thread, you release energy. A lot of energy. AMPS calculated that if you break the entanglement between the inside and the outside for every particle at the horizon, you're effectively snapping the neck of space-time. The energy released by all those broken links accumulates right at the boundary. It creates a shell of infinitely dense, high-energy particles. They called it a firewall. The implications are horrific for the astronaut falling in. According to Einstein, you should drift through the horizon into the darkness, safe and sound. According to the firewall theory, you hit a brick wall of pure energy. Imagine falling toward the black hole. You see the darkness. You expect to pass through, but the moment you touch the event horizon, you don't go through. You're incinerated, not by heat, but by a sheer wall of hard radiation. You hit a barrier that burns at the Planck temperature, the hottest temperature possible in physics. You're vaporized instantly. Your atoms are scrambled and your energy is blasted back out into the universe. There is no inside. This is the terrifying part of the firewall. It suggests that the black hole has no interior. Space ends at the horizon. The universe simply stops. There is no singularity. There is no wormhole. There is no dark room. There is just a burning wall that deletes anything that touches it and recycles it as ash. If the firewall exists, then the black hole is not a hole. It is a solid sphere of termination. It is the end of the world in the literal sense. It suggests that space-time can abruptly end, like a cliff edge, without warning. And the cost of this theory? The cost is that general relativity is wrong. Einstein's equivalence principle, the foundation of modern gravity, is a lie. Space is not smooth. In extreme conditions, space becomes brittle and snaps. This ignited a panic in the physics community. Nobody wanted the firewall to be real. It was too ugly. It was too violent. It meant giving up Einstein. So physicists scrambled to find a way to get rid of the firewall. They wanted to have their cake and eat it too. They wanted to save the information, monogamy, and keep the horizon smooth, no firewall. To do that, they had to come up with something even stranger than a wall of fire. They had to propose that the reason the firewall doesn't exist is that distance is an illusion. They had to propose that the 3D universe we see, the black hole, the stars, the galaxy, is just a projection. This brings us to the holographic principle. If you think a wall of fire is scary, wait until you hear that you might be a two-dimensional smudge of data pretending to be a person. The firewall was just the symptom. The holographic trap is the disease. This brings us to theory number 4, part 2, the holographic universe. The firewall was a disaster for physics. It suggested that space-time ends abruptly at the event horizon, turning the black hole into a solid incinerator. This violated Einstein's general relativity, the very theory that predicted black holes in the first place. Physicists were desperate to find a way out. They needed a way to save the information without burning the astronaut. They needed a way to keep the horizon smooth and safe, while still keeping the data on the outside. To do this, Leonard Susskind and Gerard 't Hooft proposed an idea so radical that it sounds like science fiction. They looked at the math of the black hole and realised something strange about how it stores information. Usually, information scales with volume. Imagine a library. If you want to store more books, you need more shelves. You need more space inside the building. The amount of information you can store depends on the 3D volume of the room. This is intuitive. This is how our world works. But black holes don't work like that. Jacob Bekenstein, a student of John Wheeler, discovered that the entropy, the hidden information, of a black hole doesn't depend on how big it is inside. It depends strictly on the surface area of the event horizon, the size of the skin, not the size of the gut. Imagine taking a book and throwing it into a black hole. Bekenstein realised that the black hole's surface area increases by a tiny precise amount, 1 Planck area, for every bit of information added. It is as if the black hole isn't a sphere filled with stuff. It is a sphere covered in pixels. This led Susskind to a terrifying conclusion. If all the information of the star, the planets, and the light that fell in is stored on the 2D surface of the horizon, then what is the 3D interior? The answer is, the interior is a projection. This is the holographic principle. It suggests that the black hole is not a solid object, and it is not a hole. It is a projector. The data, the real version of the object, is plastered on the 2D surface of the event horizon, scrambled into a chaotic soup of bits. The 3D object falling through space inside the hole is just a hologram generated by that data. Think of a hologram on a credit card. The plastic is flat, it is two-dimensional, but when you shine light on it, you see a 3D bird floating in the air. The bird looks real, it has depth, you can look around it, but the bird is not there. The reality is the flat etching on the plastic. The 3D image is a ghost. Susskind argued that the entire contents of the black hole are like that bird. The astronaut falling in thinks he is in a 3D world. He sees depth. He feels his body moving through space. But he is wrong. He is actually a scrambled smear of data stuck on the wall of the horizon. His sensation of falling is just a data processing trick. This solves the firewall paradox in a disturbing way. There is no wall of fire because there is no inside to hit. The inside is a hallucination generated by the outside. The information never technically enters the hole because the hole is just a projection of the surface. The paradox is resolved by deleting the third dimension. But here is where the horror expands. It doesn't stop at the black hole. If the laws of physics allow a black hole to be a hologram, and if black holes are just extreme examples of gravity, then what does that say about the rest of the universe? In 1997, a brilliant physicist named Juan Maldacena proved something that shook the foundations of science. He used string theory to discover the AMPS-CFT correspondence. I won't bore you with the math, but the conclusion is simple and shattering. He proved that a universe with gravity, like ours, is mathematically identical to a universe without gravity that exists on a lower dimensional boundary. Translation: our entire universe, with its billions of galaxies, its vast distances, and its deep history, might just be a hologram projected from the edge of the cosmos. Look at your hands. Turn them over. They look solid. They look three-dimensional. You can feel the space between your fingers. You trust that space. But the holographic principle suggests that this depth is a lie. The real you, the source code, is painted on a distant 2D surface at the edge of the observable universe. You're not a body moving through space. You're a cursor moving across a screen. This changes the nature of the distortion we are talking about. The distortion isn't just the bending of light. The distortion is reality itself. We are living in a low-resolution simulation generated by a hard drive we cannot see. Why is this terrifying? Because it strips us of our agency. In a 3D world, things are local. You are here, and the wall is there. There is a distance between you. But on the 2D surface of the hologram, the data that makes up you and the data that makes up the wall might be right next to each other, scrambled together in the static. It means that the separation between things is an illusion. The privacy of your own mind is an illusion. We're all just one long string of code wrapped around the horizon, and it gets worse. If we're a hologram, who is looking at the image? A hologram requires a light source to be seen. It requires an observer. If the universe is a projection, is it running for someone? Or is it a closed loop, a dream dreaming itself? This theory suggests that black holes are not exceptions to the rule. They are the rule. They are the glitches that reveal the pixelation of the screen. When we look at a black hole, we are seeing the point where the rendering engine of the universe breaks down. We are seeing the raw pixels, the Planck areas, on the screen of reality. We used to fear that black holes were monsters that would eat us. The holographic principle suggests something far scarier. We are already inside one. Think about it. We're in a universe that started with a big bang, a singularity. We are surrounded by a cosmic horizon that we cannot see past. We are living in a space that is expanding. Mathematically, the observable universe looks suspiciously like the interior of a black hole. Maybe that's why we can't find the edge. Maybe that's why the math works the way it does. We are not the explorers of the void. We are the projections on the wall of a much larger, darker container. We are the shadow puppets. And if we are shadows, what happens if the light goes out? This leads us to the final part of this specific spiral. If the universe is a hologram, and if reality is just information processing, then what happens when the computer makes a mistake? What happens when the projection flickers? This brings us to theory number 4, part 3, the simulation hypothesis and the limit of resolution. If the holographic principle is true, it changes everything. It changes the definition of you. You are no longer a biological organism made of cells occupying a specific volume of space. You are a biological algorithm. You are a complex pattern of information smeared across a two-dimensional surface at the edge of the cosmos, and your sensation of walking through a three-dimensional room is just the user interface of the projection. This sounds like philosophy. It sounds like the Matrix. But you need to understand that this is not coming from science fiction writers. It is coming from string theorists and cosmologists who are trying to make the math of gravity work. Juan Maldacena's discovery of the AMPS-CFT correspondence, the bridge between a universe with gravity, like ours, and a flat boundary without gravity, is considered one of the most important discoveries in the history of physics. It doesn't just say the universe could be a hologram, it says that mathematically, the hologram is the more fundamental truth. The 3D world is just the shadow. So if we are shadows, what is the resolution of the shadow? This is where the horror becomes tangible. Every image has a limit. If you look at a photo on your computer screen, it looks smooth. But if you zoom in, eventually you see the squares, you see the pixels, you hit the limit of the information density. Does the universe have pixels? According to general relativity, space is smooth. You can zoom in forever. You can divide a meter into a centimeter into a millimeter into a nanometer, and keep going down to infinity. It is a continuous fluid. But the holographic principle says no. It says there is a hard limit to how much data can be stored on the surface of the horizon, 1 bit per Planck area. This means the universe is digital, not analog. It means there is a minimum grid size. If you zoom in on reality, past the cells, past the atoms, past the protons, past the quarks, eventually you should hit the grain of the film. You should see the point where the geometry of space-time breaks down into jagged blocks of information. And here is the terrifying part. We might have already seen it. In Hanover, Germany, there is an experiment called GEO 600. It is a gravitational wave detector, a smaller cousin of the giant LIGO detectors that found the black hole collisions. It works by shooting lasers down long vacuum tubes and measuring the interference patterns to detect tiny ripples in space-time. It is incredibly sensitive. It is designed to measure changes in distance smaller than a proton. For years, the physicists running GEO 600 were plagued by a mystery. There was a noise in the data, a persistent, unexplained fuzziness in the signal. They checked the lasers, they checked the mirrors, they checked the seismic isolation. They couldn't get rid of it. Then Craig Hogan, a physicist from Fermilab, made a chilling prediction. He calculated what the holographic noise of the universe would look like. If the universe is a hologram, the 3D projection is inherently blurry at the microscopic scale, because the information on the 2D surface has to be stretched to fill the 3D volume. It's like taking a small JPEG image and stretching it to fit a giant billboard. It gets pixelated, it gets noisy. Hogan predicted exactly the kind of noise GEO 600 was seeing. The implication is heart-stopping. That noise in the laser signal might not be a mechanical error. It might be the quantum jitter of space-time itself. The scientists at GEO 600 might have inadvertently zoomed in too far on the image of reality and seen the pixels. They might have bumped into the resolution limit of the simulation. If this is confirmed, and experiments are ongoing, it means we are living in a low-resolution universe. It means the distortion is built into the fabric of existence. We are low-poly creatures convincing ourselves we are high-definition. This leads to a deep existential vertigo. If we are a projection, where is the projector? Where is the surface? The math suggests the surface is the cosmological horizon, the edge of the observable universe, 46 billion light-years away. That is the shell. We are the ghost in the shell. Everything that happens here, your thoughts, your movements, the fusion in the sun, is actually a computation happening on that distant shell. This brings us dangerously close to the simulation hypothesis. If the universe is made of information, and if that information is processed on a 2D chip to create a 3D environment, then the difference between physics and software disappears. A black hole is just a region where the hard drive has been formatted. The speed of light is just the clock speed of the processor. Quantum mechanics is just the logic gate system to save memory by only rendering things when they are observed. We are terrified of artificial intelligence creating a fake world. But the holographic principle whispers that we are already in one. We are data, and data can be corrupted, data can be copied, data can be deleted. But there is one final twist to the holographic. Nightmare. If our universe is a hologram projected from a boundary, and if black holes are also holograms projected from a boundary, what is the relationship between us and them? We know that black holes exist inside our universe. Does that mean we are a hologram containing smaller holograms, like a set of Russian nesting dolls? This leads us to the next great theory, a theory that explains where our universe came from and why it looks so much like the interior of a black hole. It suggests that the Big Bang was not the beginning. It was the other side of an event horizon. We are about to step out of the illusion of the hologram and into the belly of the beast. We are going to explore the possibility that our entire reality, everything we see and know, is simply the debris falling inside a supermassive black hole in a parent universe we will never see. We're not just living in a projection, we're living inside a corpse. This brings us to the fifth spiral of distortion, the Matryoshka Universe. We have spent a lot of time looking at the black hole as a tomb, a place where matter goes to die, where information is erased, and where space ends. But nature is rarely so wasteful. In biology, death is almost always the precursor to birth. A seed must fall and rot to create a tree. A star must die to create the heavy elements in your blood. So, what if the black hole is not a tomb? What if it is an egg? This brings us to the fifth spiral of the distortion. The theory that connects the monster in the dark to the origin of everything light. It suggests that our universe is not unique, and it is not alone. It is a child, and its mother is a black hole in a universe we will never see. To understand this, we have to look at the two most important events in the history of time, the Big Bang and the black hole collapse. At first glance, they look like opposites. The Big Bang is an explosion. It is matter rushing outward, expanding, cooling, and creating structure. A black hole is an implosion. It is matter rushing inward, contracting, heating, and destroying structure. But if you look at the math, specifically the Penrose-Hawking singularity theorems, you notice something disturbing. They're identical. They are mirror images of each other. A black hole is a singularity in the future. The Big Bang is a singularity in the past. If you were to film a black hole collapsing and play the movie backward, it would look mathematically indistinguishable from the Big Bang. This led physicists like Lee Smolin and Nikodem Poplawski to ask a dangerous question. Are they the same event seen from two different sides? This is the hypothesis of cosmological natural selection. It proposes that when a massive star collapses in our universe, it doesn't just crush matter into a point and stop. The singularity punches a hole through the fabric of space-time. But it doesn't lead to nowhere, it bounces. The intense gravity causes a quantum bounce that expands outward on the other side, creating a new bubble of space-time. From the outside, our universe, it looks like a black hole. It looks like a dead end. But from the inside, the new universe, it looks like a Big Bang. It looks like a sudden hot expansion of energy appearing out of nowhere. This means that every single black hole in our sky, every stellar corpse, every supermassive giant, is the seed of a new universe. Let that scale sink in. There are estimated to be 40 quintillion black holes in the observable universe. If this theory is true, then our universe is not a lonely island. It is a mother of 40 quintillion children. It is a factory of realities. But Lee Smolin took this idea one step further, and this is where it gets truly mind-bending. He applied Darwinian evolution to physics. In biology, natural selection favours organisms that are good at reproducing. If a mutation helps you have more babies, that mutation dominates the gene pool. Smolin argued that the same logic applies to universes. Imagine a baby universe is born inside a black hole. It inherits the laws of physics from its parent, but with tiny mutations. Maybe the force of gravity is slightly stronger. Maybe the speed of light is slightly slower. These are the genes of the universe. If a universe is born with laws that prevent black holes from forming, for example, if gravity is too weak to crush stars, then that universe is sterile. It cannot reproduce. It lives, dies, and has no offspring. It is an evolutionary dead end. But if a universe is born with laws that are perfect for making black holes, like our universe, which is absolutely packed with them, then that universe will have trillions of children. Those children will inherit the black hole-friendly laws. Over eons of cosmic time, the multiverse fills up with universes that are optimized for creating black holes. This explains one of the biggest mysteries in science, the fine-tuning problem. Physicists have always wondered why the laws of nature seem so perfectly tuned for life. If gravity was slightly stronger, stars would burn out too fast. If it were slightly weaker, stars wouldn't form at all. We used to think this was luck, or evidence of a god who wanted us to be here. Cosmological natural selection says, no, the universe isn't tuned for you, it is tuned for black holes. We're just a byproduct. Think about it. What does life need? It needs carbon, oxygen, and heavy elements. Where do those come from? They come from massive stars exploding in supernovas. What does a black hole need? It needs massive stars exploding in supernovas. the conditions required to make life are exactly the same as the conditions required to make black holes. We are not the purpose of the universe. We are the mould growing on the reproductive organs of a cosmic beast. The universe wants to make black holes to pass on its genes. We are just the accidental chemistry that happens in the process. This theory removes us from the centre of importance, but it gives us a terrifying context. It means we are part of a lineage, a cosmic family tree. And if our universe is a mother to trillions of black holes, logic dictates that it must also be a daughter. This is the Matryoshka Universe theory. Like the Russian nesting dolls, we are inside a universe, which is inside a universe, which is inside a universe, stretching back to infinity. This changes the nature of the Big Bang. It wasn't a random accident. It was a birth event. 13.8 billion years ago, a massive star collapsed in a parent universe. That collapse created an event horizon in that realm, a black hole. And inside that event horizon, our universe began to expand. We are living on the inside of a black hole. This isn't just a metaphor. It solves the question of what is the universe expanding into? It is expanding into the interior volume of a higher dimensional black hole. The edge of our observable universe, the cosmic horizon, is the event horizon looked at from the inside. This explains why we can never leave. We are trapped. No matter how fast a spaceship travels, it can never reach the edge of the universe, just like nothing inside a black hole can ever reach the event horizon to escape. The expansion of the universe is just the growth of the black hole in the parent dimension, as it swallows more matter. When we see the expansion of the universe accelerating, dark energy, maybe we're simply feeling the parent black hole eating a large meal. Maybe our universe is getting bigger because our mother is feeding on a star cluster in the dimension above. This is a beautiful, dizzying thought, but it leads to a darker implication. If we are inside a black hole, we are at the mercy of what happens to that black hole in the parent universe. We assume our universe will last forever, but what if our mother dies? What happens to the baby if the womb is destroyed? This brings us to the second half of this theory, the precarious nature of living inside a monster. If the black hole containing us evaporates via Hawking radiation in the parent universe, what happens to us? Do we evaporate with it? Or are we cut off, floating in a bubble of nothingness? And even worse, if we are inside a black hole, does that mean we are heading toward a singularity? Is there a point in our future where time ends? This brings us to theory number 5, part 2, the fate of the nesting doll. If we accept the hypothesis that our universe is the interior of a black hole in a higher dimension, the immediate question is, why doesn't it look like one? When we look around, we don't see a singularity crushing us. We see galaxies rushing away from each other. We see expansion, not contraction. This is where the geometry of space-time plays a trick on us. We are looking at the event from the wrong end of the arrow of time. In general relativity, equations are time-symmetric. If a black hole is a valid solution, things falling in and never coming out, then the mathematical opposite must also be valid. This opposite is called a white hole. A white hole is a region of space-time that you cannot enter. You can only leave. Matter and energy rush out of it at the speed of light, expanding into a new volume. It is a cosmic gusher. It is a singularity that explodes rather than implodes. Does that sound familiar? An explosion of energy appearing out of nowhere, expanding rapidly, creating time and space as it goes. That is the exact definition of the Big Bang, so the theory suggests a complete cycle. In the parent universe, a star collapses into a black hole. The matter falls in. It is crushed. But at the bottom of the singularity, the space-time fabric inverts. The matter bursts out on the other side as a white hole. We are living in that explosion. The Big Bang was not the beginning of everything. It was just the moment the star in the universe above us collapsed. We are the debris of a dead sun from a dimension we can't perceive, expanding into a bubble that didn't exist a microsecond before. This changes our relationship with the cosmos. We usually think of the universe as a closed system. We think the amount of energy and matter here is fixed. But if we are connected to a parent black hole, we are an open system. We are connected by a feeding tube. This leads to one of the most chilling explanations for the biggest mystery in modern cosmology: dark energy. For decades, Astronomers have been terrified by the fact that the expansion of the universe is accelerating. Gravity should be slowing things down. Galaxies should be pulling on each other, but they aren't. They are flying apart faster and faster every second. It is as if new space is being created between the galaxies. We call the force driving this dark energy, but we have no idea what it is. It is just a label for our ignorance. But the black hole universe theory offers a solution that makes too much sense to ignore. Imagine the parent black hole in the higher dimension. It is floating in space. It is not static. It is eating. Maybe it drifts into a nebula. Maybe it swallows a planet. Maybe it consumes another star. When that matter falls into the parent black hole, it adds mass to the system. That mass travels down the gravity well, passes through the singularity, and erupts into our universe, the white hole. To us, living on the inside, this new mass doesn't look like rocks or gas falling from the sky. It manifests as the expansion of space itself. Every time our mother eats a meal, our universe gets bigger. The acceleration of the expansion, the dark energy, is simply a record of the accretion rate of the parent black hole. If the expansion is speeding up, it means our mother is feeding. She is binge-eating matter in the realm above. We are being inflated like a balloon by the meal of a monster. This implies that our destiny is completely out of our hands. We are not the masters of our fate. We are the digestion process of a higher being. If the parent black hole stops eating, our expansion might stop. If the parent black hole merges with another black hole, our universe might experience a violent collision of laws, a cosmic earthquake that rewrites physics. But the ultimate terror is the death of the parent. We know that black holes are not eternal. As we discussed in Theory 3, they evaporate via Hawking radiation. They slowly bleed energy into the void until they vanish. If the parent black hole evaporates, what happens to us? There are two possibilities, and both are nightmares. Possibility A, the severing. As the parent black hole shrinks, the wormhole connecting us to it pinches off. Our universe is cut loose. We become a solitary bubble of space-time drifting in the bulk of the multiverse. We are an orphan. Without the influx of new energy, our universe slowly succumbs to entropy, which we will cover in the next spiral. We freeze to death in the dark, alone. Possibility B, the evaporation. This is worse. If we are the interior of the black hole, then the evaporation of the black hole is the evaporation of us. As the parent black hole radiates away its mass, it is radiating away our galaxies. It suggests that our universe is leaking. We are slowly dissolving back into the parent dimension as random heat. One by one, galaxies at the edge of our vision simply vanish. The fabric of our reality wears thin. Eventually, the last proton evaporates, and our entire cosmos, every memory, every star, every atom, is just a puff of steam in a cold, higher dimensional room. We wouldn't see it coming. Or maybe we already do. Maybe the Great Attractor, that mysterious gravitational anomaly pulling our galaxies toward a point we can't see, is the drain. Maybe we're already swirling around the exit, waiting to be flushed out of existence. This theory, the Matryoshka Universe, takes away our uniqueness. It makes us one of infinite bubbles. But it also traps us. If we're inside a black hole, we can never leave. The speed of light is the speed limit of the prison. The event horizon is the wall. We are serving a life sentence in a cell that is getting bigger but is still a cell. And if we look forward in time, we see that we are not just victims of black holes. We are becoming them. The universe is aging. The era of stars is ending. We are moving into an era where the only things left alive will be the monsters. This brings us to the sixth spiral of the distortion, the future. We leave the question of where did we come from and face the question of where are we going. We are heading toward the final tomb. The era where the lights go out and the universe becomes a graveyard populated solely by the things that ate us. Theory number 6, the black hole era and the heat death. Theory number 6, the black hole era. We have talked about black holes as objects in space. We have talked about them as monsters that eat planets, erase history, and perhaps birth new universes. But we haven't talked about their true purpose. To understand why black holes really exist, you have to stop thinking in terms of human years. You have to stop thinking in terms of thousands, millions, or even billions of years. You have to think in terms of deep time. Humans have existed for roughly 200,000 years. The Earth has existed for 4.5 billion years. The universe has existed for 13.8 billion years. To us, this feels like an eternity. We call it ancient. But if you look at the timeline of the cosmos from the beginning to the end, 13.8 billion years is nothing. It is less than a blink. It is the opening credits sequence of the movie. We are living in a very specific, very brief period of cosmic history known as the Stelliferous Era, the era of stars. This is the only time in history when the universe will be lit up. It is the party phase. Energy is abundant. Stars are burning hydrogen. Life is possible. You can look up and see galaxies, but the party is ending. In fact, it is already winding down. The peak of star formation happened billions of years ago. The universe is already producing fewer stars than it used to. We are living in the autumn of the cosmos, and winter is coming, a winter that will last forever. To understand the black hole era, we have to fast forward. Let's accelerate the clock. First, we watch the sun die in 5 billion years. It swells into a red giant swallowing the Earth before collapsing into a white dwarf. Then, we wait. We wait for the Milky Way to collide with Andromeda in 4 billion years. They merge into a single, massive elliptical galaxy. The night sky changes. It becomes a haze of bright cores. But then, the lights start going out. The massive stars die first. They explode as supernovas and leave behind neutron stars and black holes. The medium stars like our Sun fade into white dwarfs. They sit there, slowly cooling, like embers in a dying fire. The last to die are the red dwarfs. These are the tiny, efficient stars that burn their fuel slowly. They can live for trillions of years. Proxima Centauri will still be burning long after our Sun is a cold rock, but eventually even they run out of gas. One by one, the stars in the sky wink out. The last star in the universe will be a small, lonely red dwarf. It will burn alone in the dark for a few trillion years, and then it will sputter, fade, and die. When that last star dies, the universe will be roughly 100 trillion years old. This marks the end of the Stelliferous Era. The universe will never generate light again. There will be no more fusion, no more warmth, no more days, just an endless, freezing night. Welcome to the Degenerate Era. In this era, the universe is a graveyard. It is filled with the corpses of stars, white dwarfs, neutron stars, and brown dwarfs, and of course, the black holes. For a while, things happen in the dark. Dead stars collide. Occasionally, two white dwarfs hit each other and create a brief supernova flash, a ghost light in the tomb. But gravity is relentless. It cleans the house. Over eons, dead stars interact with each other. When they pass close by, one gets kicked out of the galaxy into the void, and the other loses energy and falls toward the center. The galaxy begins to evaporate. 90% of the dead matter is ejected into the empty space between galaxies to drift forever. The remaining 10% falls into the center, and what is in the center? The supermassive black hole. It has been waiting, it has been patient. As the dead stars spiral inward, the monster feeds. It grows larger and larger. It swallows the neutron stars. It swallows the white dwarfs. It cleans the plate. Eventually, the protons themselves, the building blocks of matter, may begin to decay. If grand unified theories are correct, protons are not immortal. They have a half-life. If you wait long enough, 10 to the power of 37 years, matter itself begins to dissolve. The dead planets, the asteroids, the dust, they simply fall apart into radiation. When the protons are gone, the only things left are the black holes. We have now entered the black hole era. This will begin roughly 10 to the power of 40 years from now. That is a 1 followed by 40 zeros. It is a number so big that trillion is basically zero compared to it. In this era, there is no matter. There are no atoms, there is no chemistry, there is no biology. There is only gravity and curvature. The universe consists entirely of black holes sailing through an expanded empty void. Some are stellar mass, the size of cities. Some are supermassive, the size of solar systems. They are the lords of the wasteland. They are the only structures that survive the decay. They are the victors of the cosmic game. This is why they terrify scientists, because they are the ultimate state of the universe. We, living beings, made of warm atoms, are just a temporary glitch. We are a foam that appeared for a split second on the surface of the ocean. The black holes are the ocean. Imagine a universe where the nearest object is 1 billion light-years away, and that object is a sphere of pure darkness. It is a universe of total isolation. If you were a consciousness surviving in this era, you would see absolutely nothing. No stars, no nebulae, just blackness in every direction forever. But even here, in the total silence of the deep time, physics is not done. The black holes are not static. They are still active, they are still processing information, and they are slowly, very slowly, dying. This brings us back to Stephen Hawking. Remember Hawking radiation? We talked about it earlier as a way to delete information. Now, in the black hole era, it becomes the only mechanism left in the cosmos. In the vacuum, the black holes are radiating. They are glowing with a temperature that is almost absolute zero, but not quite. They are bleeding their mass into the nothingness. This process is agonizingly slow. For a black hole with the mass of the Sun to evaporate takes 10 to the power of 67 years. For a supermassive black hole, it takes 10 to the power of 100 years. A Google years. To understand how long that is, if you were to count every single atom in the observable universe, you would only reach roughly 10 to the power of 80. The life of a supermassive black hole is longer than the number of atoms in the universe. So, the future of the universe is not a bang. It is a long, slow vigil. The black holes will sit there, guarding the void for eons upon eons, slowly shrinking one photon at a time, but they don't go quietly. When a black hole gets small, when it reaches the end of its life, it gets hotter, it radiates faster. The final moments of a black hole are not silent, they are explosive. This leads us to the final act of the cosmic play, the moment when the last monster dies and the universe truly becomes nothing. This brings us to theory number 6, part 2, the final firework and the heat death. We are now deep in the black hole era. The clock reads 10 to the power of 60 years. The stars are long gone, the galaxies have dissolved. The universe is a vast expanding ocean of darkness, populated only by isolated black holes drifting through the void. They are the emperors of nothing, holding on to the last concentrated reservoirs of mass in existence. But even emperors must die. As we discussed, Stephen Hawking proved that black holes are not truly black, they leak. Due to quantum effects at the horizon, they emit particles, they lose energy. For a massive black hole, this process is agonizingly slow. A supermassive giant like the one at the center of the Milky Way is radiating at a temperature far colder than the vacuum of space. It is actually absorbing more energy from the cosmic background radiation than it is emitting. It is still growing, technically. But the universe is expanding. The background radiation is cooling. Eventually the universe becomes colder than the black hole. That is the tipping point. The black hole begins to starve. It stops growing and starts shrinking. The evaporation process is a runaway feedback loop. As a black hole gets smaller, it gets hotter. As it gets hotter, it radiates faster. A black hole the size of a mountain radiates heat like a kitchen oven. A black hole the size of an atom radiates like a nuclear bomb. So, the life of a black hole follows a pattern. Trillions upon trillions of years of slow, invisible leakage, followed by a sudden, violent acceleration at the very end. Let's fast forward to the death of the very last black hole in the universe. It has drifted alone for a Google years. It has shrunk from the mass of 1 billion suns down to the mass of an asteroid, then a rock, then a dust grain. In its final few seconds, the monster screams. It releases all of its remaining energy in a blinding flash of gamma rays and high-energy particles. It triggers a massive explosion, comparable to 1 billion nuclear warheads detonating at once. It is a last firework, a momentary spark of light in a universe that has been dark for an eternity. And then, silence. The black hole is gone. The event horizon has vanished. The knot in space-time has untied itself. The information it held has been scattered into random heat. This brings us to the final state of reality, the dark era, or, as physicists call it, the heat death. The term heat death is confusing. It sounds like the universe burns up. It actually means the opposite. In thermodynamics, heat refers to the transfer of energy. Energy only moves when there is a difference in temperature. A steam engine works because the fire is hot and the water is cool. Life works because the sun is hot and space is cold. Life is just a way of processing energy, as it flows from a hot source to a cold sink. But now, the black holes are gone. Everything is gone. The universe consists entirely of a thin soup of photons and neutrinos, stretched out over trillions of light years. Every point in the universe is at exactly the same temperature. Absolute zero. This is maximum entropy. Because there is no temperature difference, energy cannot flow. If energy cannot flow, work cannot be done. If work cannot be done, nothing can happen. The universe has reached a state of perfect, eternal equilibrium. It is a frozen pond that will never ripple again. This has a terrifying implication for time. What is time? Time is a measurement of change. We know time is passing because things move, things decay, things happen. But in the heat death, nothing changes. The arrangement of particles at this moment is statistically identical to the arrangement of particles in 1 trillion years. If nothing changes, time loses its meaning. The arrow of time breaks. The universe enters a state of timeless suspension. It is not dead. It is worse. It is finished. It is a static image that will never change, frozen in the dark forever. This is the ultimate tomb. It is not just the death of life, it is the death of possibility. And here is the deepest horror of the heat death. It is the perfection of the eraser. In Theory 3, we worried about black holes deleting information. But in the heat death, the entire universe becomes a deletion machine. With the particles scattered so thin and the energy so low, there is no way to reconstruct the past. If you were a god looking at this cold soup, you would find no evidence that humans ever existed. You would find no evidence of the Earth, the Sun, or the Milky Way. You would find no evidence that there was ever a Big Bang. The universe has perfectly scrubbed the crime scene. It has forgotten itself. This effectively means that our existence leaves no trace. We are a momentary hallucination in a system that eventually settles into zero. This realization that the universe is heading toward a state of absolute nothingness is the source of cosmic nihilism. It makes everything we do feel small. Why build a legacy if the canvas itself will be destroyed? But there is one place that defies this logic, one place where the rules of entropy, time, and death do not apply, a place where the math suggests that zero and infinity exist at the same time. We have explored the outside of the black hole, we have explored the horizon, we have explored the future, but we have avoided the center. We have avoided the point where the actual monster lives, the singularity. It is the heart of the distortion. It is the place where the black hole does not just break the laws of physics, it mocks them. It is a point of infinite density and zero volume, a point where space and time are crushed out of existence. Some scientists believe the singularity is a mistake in the math. Others believe it is the only real thing in the universe. And some believe it is a gateway to the past, allowing us to escape the heat death by looping time itself. We are going to finish our spiral by looking at the thing Einstein refused to believe in. We are going to look at the center of the drain. This brings us to the final and most maddening theory. Theory number 7, the singularity and the closed Timelike curve. We have travelled a long way. We have watched the human body ripped apart by tidal forces. We have watched the Earth ejected into the frozen void. We have watched our history deleted, our reality revealed as a hologram, and our universe dissolve into the heat death. But throughout this entire journey, we have skirted around the edge of the true horror. We have looked at the event horizon, the shell, the shadow. We have avoided looking directly at the thing that creates the shadow. We have avoided the center. This brings us to the 7th and final spiral of the distortion. The singularity. To understand why this single point terrifies scientists more than anything else we have discussed, you have to understand what it represents. It does not represent a thing. It represents a failure. When Carl Schwarzschild first solved Einstein's equations in 1916, he found a point at the center of the black hole where the math simply stopped working. The radius of the mass became zero. The density of the mass became infinite. In mathematics, infinity is not a number, it is a concept. It is a way of saying, this goes on forever. But in physics, infinity is illegal. You cannot have infinite heat, you cannot have infinite energy, and you certainly cannot have infinite density. If you have a physical object, a star, a planet, a person, and you crush it down to zero volume, you are dividing by zero. If you pull out your calculator and try to divide 1 by 0, it gives you an error. It crashes. It tells you that the operation is undefined. It has no logical answer. The singularity is the universe dividing by 0. It is a point where the fabric of space-time is curved so sharply that it tears. It is not a hole in the universe. It is a whole of the universe. It is a place where the laws of physics do not just break, they cease to exist. At the singularity, there is no space. You cannot move left or right. There is no time. The past and future fuse into a single crushed moment. Cause and effect, the bedrock of logic, dissolve. Einstein hated this idea. He believed that the universe was a logical place. He believed that if you followed the rules of physics, they would always give you a sensible answer. The singularity was an insult to his life's work. It was a sign that the theory was incomplete. He spent decades trying to prove that nature would protect itself from forming such an abomination. He failed. Roger Penrose and Stephen Hawking proved in the 1960s that singularities are not accidents, they are inevitable. If you get enough mass in one place, gravity wins. It crushes the matter past the electron pressure, past the neutron pressure, and keeps crushing it until it occupies no space at all. So, the monster is real, and it is sitting at the centre of every galaxy, mocking us. But nature seems to know that this thing is an abomination. Nature seems terrified of its own creation. This is why the event horizon exists. Think about it. The event horizon is a cloak. It is a cosmic quarantine zone. It wraps the singularity in a shroud of darkness so that nothing in the outside universe can ever see it. This leads to a hypothesis known as cosmic censorship. It suggests that the laws of physics actively conspire to hide singularities. Nature forbids a naked singularity. Why? Because if a singularity were visible, if we could look at it without the black veil, we would see the laws of physics breaking down. We would see the raw, chaotic code of reality. And if we saw that, unpredictability would leak out into the universe. Logic would crumble. So the black hole is a prison built to keep the singularity from infecting the rest of space-time with madness. But what if you go inside? What if you cross the horizon and confront the beast? As you fall toward the center, the geometry of the world changes. We are used to 3 dimensions of space and 1 dimension of time. But near the singularity, space becomes space-like, and time becomes time-like in ways our brains cannot process. The tidal forces become infinite, the curvature becomes infinite, but the real problem is the clash of the titans. At the singularity you have a massive amount of gravity. Gravity is the domain of general relativity. But you also have a tiny microscopic point. Small things are the domain of quantum mechanics. Usually these 2 theories stay in their own lanes. Relativity handles stars. Quantum mechanics handles atoms. They never talk to each other. But at the singularity they are forced into a cage match. They are both trying to describe the same point at the same time, and they disagree violently. General relativity says the singularity is smooth and infinitely precise. Quantum mechanics says the singularity is a jittery, chaotic foam where nothing can be precise. When physicists try to combine the math, the equations explode. They yield nonsense answers like, the probability of this happening is infinity%. This tells us something profound. It tells us that our understanding of the universe is a lie. General relativity and quantum mechanics cannot both be right. One of them, or both of them, is wrong. The singularity is the evidence of our ignorance. It is the finger pointing at the flaw in our science. We don't know what happens there. We genuinely don't know. Does matter disappear? Does it tunnel to another dimension? Does it turn into a fuzzball of strings? Or does it do something even stranger? There is a solution to Einstein's equations that suggests the singularity is not a point, but a ring. A spinning ring of doom. And if the singularity is a ring, then the center is not a dead end. It is a doorway. If you approach a static singularity, you die. You are crushed. But if the black hole is spinning, and all black holes spin, the singularity spreads out into a ringularity. And the math suggests that if you approach this ringularity at the right angle and speed, you might not be crushed. You might pass through the middle of the ring. Pass through to where? This is where physics turns into science fiction, but the math is disturbingly solid. Passing through the ring might not just take you to another place, it might take you to another time. It opens the door to closed time-like curves, time travel. the ability to loop back and meet your past self. This leads us to the final shattering conclusion of the distortion, the idea that black holes are not destroyers of time, but machines that allow us to break the arrow of time itself. This brings us to theory number 7, part 2, the time machine and the grandfather paradox. We have spent this entire documentary terrified of the singularity. We have pictured it as a tiny, infinitely dense point that crushes everything it touches. A dead end. A period at the end of the sentence of your life. But there is a twist. A literal twist that changes the singularity from a weapon of destruction into a machine of impossibility. The point singularity, the one Schwarzschild calculated in the trenches, is based on a black hole that is standing perfectly still. But in the real universe, nothing stands still. Planets spin, stars spin, galaxies spin. When a massive star collapses, that spin doesn't disappear. In fact, due to the conservation of angular momentum, it speeds up. Like a figure skater pulling in their arms, the collapsing star spins faster and faster. By the time it becomes a black hole, it is spinning at a significant fraction of the speed of light. This is called a Kerr black hole, and the geometry of a Kerr black hole is completely different from the static monster we have been fearing. Inside a spinning black hole, the singularity is not a point. The centrifugal force of the violent rotation pulls the singularity outward. It stretches it. It opens it up. It transforms the center of the black hole into a ring, a ringularity. This ring has zero thickness, but it has a radius. It is a razor-thin circle of infinite density floating in the dark, and because it is a ring, the center is empty. Do you understand what this means? If the singularity is a ring, you are not forced to hit it. In a static black hole, all paths lead to the center. You must die. But in a spinning black hole, if you approach the center at the right angle and the right speed, you can fly through the ring. You can pass through the eye of the needle. And what happens on the other side? This is where general relativity goes from weird to insane. The math suggests that the space inside the spinning black hole is dragged around so violently, a phenomenon called frame dragging, that space and time swap roles twice. When you cross the outer event horizon, you are trapped. You must fall in. Time becomes space. But spinning black holes have a second horizon deep inside called the Cauchy horizon. When you cross this second line, space and time flip back. You regain your freedom. You can move around again. You can fire your rockets and steer your ship. But you're now in a region of space-time that defies logic. You're in a region containing closed time-like curves, CTCs. A closed time-like curve is the physicist's technical term for a time machine. In our normal universe, your world line, the path you take through life, is a straight line. You move from the past to the future. You can never go back. But in the twisted geometry near the ringularity, the space-time is curved into a loop. If you follow a closed time-like curve, you're moving forward in your own local time. You feel like you're aging. You watch the clock tick forward. But the path you're taking through space-time curves back on itself. If you complete the loop, you don't arrive at a new place. You arrive at a previous time. You arrive at yesterday. This is not a metaphor. The equations of general relativity, the most tested theory in science, allow for this solution. A rotating black hole is a gateway to the past. Imagine the horror of this. You fly your ship through the ring, you circle the core, you check your navigation computer. It tells you that you are now arriving at the coordinates of your entry, 5 minutes before you entered. You look out the window. You see your own ship, 5 minutes younger, preparing to enter the black hole. You're now in a universe where cause and effect are broken. If you can see your past self, you can interact with your past self. You can shoot your past self. But if you shoot your past self before you entered the hole, then you never entered the hole. If you never entered the hole, you never shot yourself. So you did enter the hole, so you did shoot yourself. This is the grandfather paradox. It is usually treated as a fun philosophical puzzle, but in the context of the singularity, it is a nightmare. It means that history is not consistent. It means the universe is capable of entering a state of logical contradiction. A universe that allows paradoxes is a universe that is broken. It suggests that reality is not a solid construct, but a glitchy simulation that allows for fatal errors. If closed time-like curves exist, then the entire concept of free will is dead. Because if you travel back in time, you're already part of the history you're visiting. You're trapped in a loop of events that have already happened. even though they are in your future. You're a puppet on a string of infinite curvature, but there is a fail-safe. The universe seems to hate time travel, it seems to hate paradoxes, and it has a mechanism to stop you from using the Singularity as a DeLorean. It is called the instability of the Cauchy horizon. Remember, to reach the time machine you have to cross the inner horizon. But as you approach this inner horizon, something terrifying happens. You look back at the universe outside. Because of the extreme time dilation, time outside is speeding up relative to you. As you hover just above the inner horizon, the entire history of the external universe flashes by in a split second. You see stars die. You see galaxies merge. You see the heat death. But you don't just see it, you feel it. Light carries energy. The light from the entire future history of the universe is falling into the black hole behind you. Due to the time dilation, all that light, billions of years of starlight, radiation and cosmic rays, is compressed into a single instantaneous flash. This is called the blue sheet. As the light falls in, it is blue shifted. Its frequency is increased to infinity. The moment you try to cross the threshold into the time machine, you're hit by a wall of infinite energy. You're hit by the concentrated radiation of the entire history of the cosmos. You are vaporized. Not by the Singularity, but by the universe protecting its own timeline. The blue sheet acts as a firewall for causality. It burns you alive to prevent you from breaking history. So the Singularity offers a tease. It offers a doorway to the past, a way to escape the death of the universe, a way to become a god. But it places a wall of infinite fire in front of the door. Or does it? New simulations suggest that for rotating black holes, the blue sheet might not be infinite. It might be survivable. The mass of the black hole might dampen the radiation just enough to let you through. If that is true, then the paradox is real. The madness is real. Somewhere in the center of the galaxy there is a place where time is a circle, and ghosts haunt their own pasts. But let's assume you can't survive. Let's assume the Singularity is the end. We have now reached the absolute limit of the spiral. We have looked at the physical death, the logical death, and the temporal death. We have stripped the universe of its safety, its history, and its future. So, where does that leave us? It leaves us with one final question. A question that justifies the fear. Why does our brain, a biological machine evolved to hunt gazelles on the savannah, have the ability to understand this? Why are we the only thing in the universe that can look at the monster and know that it is a monster? This brings us to the final conclusion. The reason we stare into the distortion. It is not because we are afraid of the dark. It is because we are the only part of the dark that has woken up. We are standing at the end of the line. We have looked at the black hole as a meat grinder, a portal, a hologram, and a time machine. But all of these theories share one fatal flaw. They are all guesses. They are educated guesses, yes. They are guesses written in the language of advanced calculus and differential geometry. But they are still guesses. Because the truth is, when we look at the center of a black hole, we are not looking at a physical object. We are looking at a mirror that reflects our own limitations back at us. This brings us to the final, and perhaps most disturbing aspect of the Singularity. It is not just a region where space breaks. It is the region where we break. It represents the absolute limit of human knowledge. For the last 400 years, since Galileo pointed a telescope at the sky, the story of science has been a story of victory. We conquered the mystery of the motion of planets, Newton. We conquered the mystery of electricity, Maxwell. We conquered the mystery of the atom, Bohr, and the mystery of gravity, Einstein. We grew arrogant. We began to believe that the universe was a puzzle, and that we were the masters who could solve it. We believed that with enough time and enough math we could understand everything. We thought we could write down the theory of everything, a single equation that fits on a t-shirt and explains the entire cosmos. But the black hole stands in the way. It is a stone wall built across the highway of human progress. The problem is the clash we mentioned earlier. General relativity, the physics of the big, and quantum mechanics, the physics of the small, are the two pillars of modern science. They are both incredibly successful. Your GPS works because of relativity. Your smartphone works because of quantum mechanics. They are both true. But at the Singularity, they cannot both be true. Relativity says the center is smooth and deterministic. Quantum mechanics says the center is jagged and probabilistic. When we try to merge them into a theory of quantum gravity to explain the black hole, the math falls apart. We have spent 80 years looking for this theory. We have invented string theory, loop quantum gravity, causal dynamical triangulations. We have filled blackboards with 11-dimensional geometry, but we still don't know what happens at the centre. This failure suggests a terrifying possibility, a possibility that most scientists are afraid to whisper. What if there is no answer? What if the universe is not a puzzle designed to be solved? What if the laws of physics are just local guidelines that work in our safe, cold, low-gravity neighbourhood, but dissolve completely in the extreme? We assume that math is the universal language. We assume that 1 + 1, 2 everywhere, even inside a black hole. But the singularity challenges this. It suggests that logic itself might be a property of smooth space. If you crush space out of existence, maybe you crush logic out of existence too. This is the Lovecraftian horror of the black hole. H.P. Lovecraft wrote about monsters that were so alien that simply looking at them drove humans insane. The singularity is that monster. It is a concept that the human brain, a biological wet computer evolved to hunt gazelles on the African savannah, is literally incapable of processing. We are like ants crawling on a circuit board. The ant can understand the plastic, it can understand the heat, but it can never ever understand the software running on the chip. The black hole is the chip. We are the ants, and the universe seems to be actively trying to stop us from learning the secret. Remember the event horizon? It hides the singularity. Remember the blue sheet? It burns you if you try to enter the inner horizon. Remember cosmic censorship? The hypothesis that nature forbids naked singularities. It feels like a conspiracy. It feels like the universe has built-in defense mechanisms to prevent observers from seeing the source code. Every time we get close to the truth, a wall of fire, or a horizon of darkness, or a paradox of time pops up to block our view. Why? Maybe because the truth is too simple, or maybe because the truth is too chaotic. There is a theory called the mathematical universe hypothesis, which states that physical reality is mathematics. If that is true, then the singularity is a division by zero error. If you divide by zero on a computer, the program crashes. Perhaps the black hole is where the simulation of reality crashes. The event horizon is just the blue screen of death, masking the error so the rest of the system doesn't freeze. If we were to somehow peek behind the curtain, if we could send a probe into the singularity and get the data back, we might find that there is nothing there. No quantum foam, no strings, no wormholes, just void. Or worse, we might find that the laws of physics change randomly every second, a chaos so profound that existence loses its meaning. This realization brings us to a place of humility. We are not the masters of the universe. We are huddled around a campfire in a vast dark forest. The fire is our science. It lights up a small circle around us. It lets us see the trees and the rocks nearby. But the black hole is the thing waiting just beyond the edge of the light. It reminds us that our light is small. It reminds us that the forest is deep. It reminds us that we are not the main characters. The black hole does not care about our math. It does not care about our philosophy. It does not care if we solve the paradox. It simply is. It is the great silent giant that holds the galaxy together and eventually will tear it apart. So we are left with the distortion. We look at the black hole and we see our own reflection. We see our fear of death, spaghettification. We see our fear of the dark, the void. We see our fear of being forgotten, information loss. And we see our fear of being stupid, the singularity. The black hole is the ultimate Rorschach test. It reflects our deepest anxieties about existence back at us. And that leads us to the end. We have stared into the abyss for 2 hours. We have stripped away the comfort of the stars. We have stripped away the safety of the ground. We have stripped away the certainty of time. You might feel small right now. You might feel terrified. You might feel like nothing matters because we are just dust destined to fall into a drain. But there is another way to look at it. There is a way to look at the monster and smile. There is a perspective that takes all this horror and turns it into the most empowering thought you will ever have. We're going to finish this journey not with a scream but with a realization. We're going to turn on the lights. This brings us to the conclusion. The optimistic nihilism of the distortion. We have reached the end of the spiral. For the last 2 hours we have dissected the darkest corners of reality. We have watched the human body being shredded into atoms by tidal forces. We have watched our solar system being ejected into the frozen void by invisible stalkers. We have seen our history erased by the information paradox, our reality exposed as a low-resolution hologram, and our future condemned to the eternal freeze of the heat death. We have looked into the singularity and seen the laws of logic shatter like glass. If you're feeling small right now, that is normal. If you're feeling terrified, that is a sign that you're paying attention. The human brain is not designed to handle these scales. We are designed to worry about social status, paying rent, and finding food. We are not designed to worry about the evaporation of the cosmos or the collapse of time. So, why did we do this? Why spend this time staring into the abyss? Is the point of this channel just to make you feel insignificant? To show you that you are a microscopic speck of carbon on a dust mote circling a dying star in a universe that is trying to kill you? No. The point is exactly the opposite. The horror of the black hole is real, but there is a secret hidden inside that terror. A secret that turns the fear into the most empowering thought a human being can have. Think about the black hole era we discussed, the future of the universe's darkness, trillions of years of cold, dead silence. Think about the past, the chaotic, uninhabitable fire of the Big Bang. The universe is 13.8 billion years old, and it will last for googles of years. And yet, here you are. You're alive in the stelliferous era. The only era in the entire history of time where the universe is warm. The only era where stars are shining. The only era where light can travel freely across the galaxy. You're standing in the sliver of light between two eternal darknesses. And you are not just a rock. You are an observer. The black hole, for all its power, for all its mass, for all its ability to bend time and eat light, is blind. It doesn't know it exists. It doesn't know it is huge. It doesn't know it is scary. It is a slave to gravity. It follows the rails of space-time without choice. It is a machine. But you are the universe waking up. You're a collection of atoms that has arranged itself into such a complex pattern that it can look back at the thing that made it and say, I see you. You are the universe experiencing itself. Without you, without life, without consciousness, the universe is meaningless. A play with no audience is not a play. It is just noise. You are the audience. You give the black hole its size. You give the singularity its mystery. You give the darkness its name. This leads us to the philosophy of optimistic nihilism. Yes, the black hole theories suggest that ultimately nothing matters. The heat death will erase our legacy. The information paradox might delete our past. We are living in a distortion. But if the universe has no inherent meaning, that means you are free to create your own. If the universe is a cold, uncaring void, that means nobody is judging you. Nobody is keeping score. The pressure is off. You're not destined to be anything. You're just a lucky accident of chemistry that gets to enjoy the show for a few decades. The fact that you exist at all is statistically impossible. The odds of your atoms coming together in this specific order, on this specific planet at this specific time, are so low that they are indistinguishable from zero. And yet, you are here. You beat the odds. You won the lottery of existence just by being born. So when you look at the black hole, don't feel small. Feel rare. The monster in the dark is not there to eat you. It is there to remind you of how precious the light is. Every time you look up at the night sky, you're looking at a battlefield. Gravity is trying to crush everything. Entropy is trying to freeze everything. But for now, the stars are winning. Life is winning. You are winning. We live in a distorted reality. Our eyes only see a tiny fraction of the light spectrum. Our brains filter out most of the information. We might be holograms. We might be inside a simulation. We might be the dream of a dead star. But the feelings are real. The curiosity is real. The awe is real. This is the mission of Distortion. We are not here to give you comfortable lies. We are here to explore the uncomfortable truths. We are here to peel back the skin of the universe and look at the muscle underneath, even if it's ugly, especially if it's ugly. Because truth, no matter how terrifying, is better than ignorance. The black holes will eventually win. The lights will go out. The story of humanity will end. But not today. Today we explore. Today we learn. Today we stare into the face of the monster and we do not blink. We hope this journey has changed the way you look at the dark. If you want to continue exploring the edges of reality with us, if you want to see what else is hiding in the math, join us. subscribe to the channel, turn on the notifications, because the universe is full of monsters and we have only just met the first one. There are things stranger than black holes out there. There are vacuum decays. There are Boltzmann brains. There are strange matter stars that convert everything they touch into grey goo. And we are going to find them all. Thank you for watching. Thank you for thinking. And remember, reality is just a suggestion. The distortion is the truth. See you in the next spiral.